Stat201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam! No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So, we'll see what happens.
What's up, everybody? Good to see you here. I'm back. Forgot to play the intro. He's getting some food. Got some food. Got some ice cream. Haslam. Hey, good to see you here. Jace, good to see everybody. Jason bringing me back right there. I've got the portal. Where's my portal? Up, up, up. Oh my gosh, there's my portal. I forgot to come back through my portal right here. There we go. Portal right there. I should have had the portal up and going, but I forgot to. I walked through the portal and I came back. Good to see everyone here. This Brian is sus. Brian's not sus. Brian's never sus. No sus, Brian. What is going on with the screen right here? I'll show you the screen here in a second. We'll get the Kahoot going. Good to see you here. Troopty, good to see you here. Everybody, Troopty, we'll make Troopty a mod. He's here. People saying Doctor Strange saved the day. Alyssa, good to see you here. Who wants some 100 points? Can we get some arm raised in the chat? We're going to be playing Kahoot here in a second. My screen is acting a bit weird. I don't want to... There we go. We got it fixed up. We got this fixed up. I'm ready in the chat. People are in the chat. Let's put up that Kahoot code right here. And we don't go with regular Kahoot music here. We only go with disco. That's the only way to go with Kahoot music. Only Kahoot music allowed here. What are people eating right now? I'm eating some ice cream right now. The Cookie Lovers ice cream by HEB. If you are a Texan, you know about some HEB. I'll mute. Pub sub. Chicken fingers in the chat. Caesar salad. Let's get 100 plus players. I love it when we have 100 plus. Big ZD. Ooh, ZD's good. Jake knows what's up. ATB. I'm sorry, Knoxville. I love me some Knoxville, but when I come back to Knoxville, I'm going to be missing some HEB. HEB is so good. Can we get 100? Let's put 2 minutes on the clock here, and let's start in 2 minutes. I want to see 100 plus players in the chat. I'd love that. Some burgers, some Chipotle. Chipotle's good. That Chipotle rice. Man, that rice. What's it got? That like basil in or whatever? I don't know. It's got the green things. Whatever that green stuff is good. Burger. What else are you eating in the chat right now? Just give me those extra scoops of rice. Oh, cilantro lime. That's what it is. Not parsley. Texas equals HEB. And what is Bustus? What is that? Nothing. Some Zaxby's. That's Zax sauce, though. Zax sauce. That's S tier. What's better? Zaxby's? We got to take a poll in the chat right now. Categorical question right now in the chat. Zaxby's or Cane's? How do you spell Cane's? It's Cane's like this, right? Zaxby's or Cane's? Take your vote now. 2 minutes on the clock. We're trying to get 100 people. Currently drinking Diet Coke. Diet Coke, good. Zaxby's or Cane. You can only have one or two. The rest of your life, you're only having Zaxby's or Cane. You have to have it. Not allowed to say neither. Zaxby's is winning out right there. Vote for Cane's. Uh-oh, it's getting close. You gotta get some Zax sauce if you get some. I don't get out either. I haven't had Zaxby's or Cane. I haven't had fast food since February 2020. Oh, we're losing people. What's going on? What's going on? Jason's saying Cane's has the best sauce. And if you like playing Kahoot, you can hang out for the 320 Kahoot. Cane's because I can use Flex. Nice. Flexing on that Cane's right there. Flex money. Y'all wrong if you eat at Cane's. It actually does have more options. Cane's has got the crinkle fries, right? Is that what Cane's fries look like? What is Zach's fries? No, Zach says crinkle fries too. One more minute. Benjamin asking the questions of life. Why is Cane's chicken wet? Only a few more seconds right here. We're going to finish this off. Tenders at Cane are bigger, though? Ooh, good point. I thought I dropped down my keyboard. I was like, oh, no. That'd be horrible. What are your thoughts, Lasia? Working at Cane's. Is Cane's the best? Last but ice cream. Great dinner. How dare you chew your ice cream? I'm sorry. I am sorry. No ice cream chewing allowed on this stream. You can toast your tenders in sauce. Man, it sounds so good. We're going to be starting here in about 10 seconds. You hear the bell. It's the best. Lasia has confirmed. 100 points, Lasia, and everyone else. You know what? Let's start off with some big points. Points, add viewers. Let's go 500 points of viewer here right now. Oh, thank you very much, Danav. Appreciate that. I haven't eaten fast food since February 2020. No fast food, just ice cream. First part's true, second part's not. Woo! Can we hit 100 and make this happen right here? 100 people in the chat, or 100 people in the stream on Kahoot. Let's make it happen. We're going to start here in seconds. Be ready when that hits 100. We're going to get going here and play some Kahoot. We need 100. If you're not playing right now, hop in this Kahoot. Make it happen. Here we go. I need a countdown in the chat. Get my countdown going with the 5, 4. Start that chat down. 5, 4, 3, 2, 1. Let's do this. Here we go. Time to Kahoot. First question of the night on the Kahoot. Let's do this. Quiz question. 2 events that can be easily added together must be what? Oh, we didn't do this, but now you need to know it. We're adding together 2 events. So this is the addition rule. We're adding together 2 events. This is the addition rule. We're adding together 2 events. This is the addition rule. Probably we're going to have to review this afterwards. If we're adding together 2 events using the addition rule, the 2 events, wow. I'm just going to throw out 100 points for everyone answering. Ooh. Let's review. You ready? Don't worry. It's time to review, everybody. Time to review. So when we do the addition rule, the addition rule has with it a word, it has with it a condition, and it has with it a sign. And the addition rule uses the word what. If I'm going to use, or we'll talk about the math down here for the sign. If we're going to use a word for the addition rule, what would we say? And let's talk about the addition rule right here and make sure we remember. How do we do this? What is the addition rule? The addition rule is when we say this. What do we say? We say this what? We say this what? This or this. We say this or this. So or is the word. This or this. And mathematically, it's going to look like the probability of B plus the probability, or we do A. You just start with A. Probability of A plus the probability of B. Now, I want you to think about this. In this class, and let's just think about it, you will make an A, B, C, D, or F. Like if you make a grade, we'll just assume you make a grade right here. You will make one of the following grades. And we'll draw it out as a table for the moment. We have here the probability of an event, and we have here the event itself. Now, please tell me about this. When you make an A, which I'm going to put you at a 40% probability of an A, we like that, 30% probability of a B, what do you know about making one of these grades? If you make an A, what would you know about the other grades right here? I'd love it. This might be close to some of my distributions. We got pretty good distributions. What would you tell me about, unless you drop, exactly. If you make a grade, here's the grades you will make. If you make a grade without like an incomplete or a drop, if you make a grade in a class, you'll make one of these grades. And we're talking about A's and minuses and A's in the same group. Now, what is the condition right here and how does it apply? Does it equal up? It should equal up, right? I think it does. It equals up totally. It should equal to 1, which is one of the rules. You can't, if you make 1, you can't make a different one. Does that make sense? This is what disjoint, which is the same thing as mutually exclusive. I'm running out of room now. This is the same thing right here. And let's talk about what disjoint and mutually exclusive means. Disjoint and mutually exclusive means what? If you make an A, you cannot, and watch my hands right here, you cannot make a B. If you make an A, you cannot make a B. Does that make sense to everybody right there? If you make an A, you cannot make a B. So when you say disjoint right here, there is no what between the two things. There is no what between A and B. This is not disjoint. If you're talking about disjoint right here, there is what between A and B. If you're talking about it being disjoint, there is no overlap. So in this instance right here, we have where A and B occur together, but right now we have where A and B cannot occur together. So how would disjoint look? If you're thinking about things that are disjoint, you have A, you have B, and there is no overlap between A and B. If A happens, B cannot happen. Your grades in the class are what? Say it with me one more time. Your grades in the class are what of each other? Your grades in the class are what of each other? Your grades would all be what of each other? Disjoint or mutually exclusive. They exclude each other. As soon as you know someone made an A, they didn't make a B. So be very careful right here. Disjoint applies to what rule? If we're talking about disjoint, then we can easily add together events that are disjoint, like the probability of making an A or a B or an A or B or C or D or F. We can easily add together things that are disjoint when we're doing the what rule, the addition rule. And that's when we add together things right here. So big common mistake. I like starting with this question right here. Big common mistake. And remember this as we talk about more rules. Let's see who's in the lead right here, though. Ooh, Super Zebra? I don't know if anyone's going to beat Super. Wow, that's super quick too. Holy mackerel, Super Zebra was really quick. Let's find out the next question. Who's going to win here? Next question. Here we go. Quiz question number 2. 2 events that have no influence on the probability of each other are what? 2 events that have no influence on the probability of each other. That might have been Super Zebra again right there. 2 events that have no influence on the probability of each other are going to be what of each other? 2 events that do not influence each other. Like when I talk about my brother drinking coffee, like I got my dogter mug or my fiance's dogter mug. Trust me, I'm a dogter. If I drink coffee, then my brother drinking coffee in the morning would be what of Brian drinking coffee? I drink coffee, my brother drinking coffee would be independent. Great job on this one. And this is a good definition right here. If you think about, put the dogter mug up. If you think about 2 events that do not influence each other, they're independent of each other. And where does this come into play? Who can help us review? And we're here to review, and we're here to win. Who can help us remember how 2 events that are independent of each other, how does this come into play? If 2 events are independent of each other, like we have Brian drinking coffee, he drinks coffee about 80% of mornings, and Darren drinks coffee about 40% of mornings, then what is the probability Brian and Darren both drink coffee? So this one is the AND word, so we're going to go here and go to multiplication, the multiplication rule, and this is going to have the word and the rule for it is independent, which means knowing one does not tell you anything about another. And then over here, we're going to multiply them. So we have here the probability that Brian drinks coffee. Probability Brian drinks coffee is going to be, I think I said 70%. And the probability Darren drinks coffee is going to be 40%. So what is the probability on any given morning that Brian drinks coffee and Darren drinks coffee? You kill me in the chat, Matthew. What is the probability that Brian drinks coffee and Darren drinks coffee? See if you can solve that out right here. Take a quick shot at that question. What is the probability that Brian drinks coffee and Darren drinks coffee? Bridget and Lauren, amazing job right there. 50 points in the chat. So it's 28% right there. The probability that we both drink coffee on a given morning. If you want to get complicated here, we can do a little complicated stuff. What is the probability of Brian not drinking coffee and Darren not drinking coffee on any given morning? So now we could solve for, because this is actually a disjoint event right up here, The probability of Brian not drinking coffee, Brian not drinks coffee, is going to be 30% because that's the complement review. Probability of Darren not drink coffee is 60%. And so you guys are doing great, guys, gals, everyone, all pals. You got it 18% right there, and you're just finding the complements right there. And do remember, if you're multiplying events together, 2 events that are multiplied together, and these are the keynotes. A lot of people ask me, what do I need to write down? 2 events that can be easily multiplied together must be what of each other. 2 events that can be easily multiplied together, we must ask if they're what of each other. 2 events that can be easily multiplied together, these are the keynotes you want to have written down. 2 events that can be easily multiplied together must be independent of each other. And independent means that knowing one would not influence the other. Like the previous thing we just talked about were dependent events. Even though they are disjoint also, if you know someone made an A, you know they didn't make a B, that means disjoint events are very, 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 very dependent. So independent means knowing one tells us nothing about the probability of the other. Super Zebra, are you still winning? No, Super Zebra, no. Ah, man, Super Zebra. I'm sorry, man. Play a little sad music for you here as we start up this next question. Here we go with the next question. Here we go. Quiz question number 3. To multiply the probability of A and B, the 2 events must be what? Save me here. Surely you know this. We practiced it. So if you get confused on this one, let me know. NH, was that you, Super Zebra? 2 events that we multiply together. I thought I said the answer. So when you have disjoint or mutually exclusive, you can add together. That was a review from question 1 and 2, or question 1. We don't want things to be dependent if we're multiplying things together. We want them to be independent. So good review right there. And so what are these? These are what words of each other. Who can help us remember? Oh, yes, I'm Darkrai. Yep. On Pokemon Go. Who can help us remember what these are? Do these mean the same thing? Mutually exclusive and disjoint? Who can help me out with this? Who can help me? They're synonyms. Great job, Kelsey, right there. And everyone following along, they're synonyms. So disjoint and mutually exclusive means if one happens, like it's the same thing. Disjoint, no overlap between the circles. They're exclusive of each other. Game pin on the bottom of the screen right here for you to see right there. There's the game pin. And independent is when we have the multiplication rule. Please remember and write these down if you haven't. We've got a lot of review notes up today. But here's a review sheet on the addition rule. Very simple kind of example with it. Talking about the word we use is or. The condition is this. These are synonymous words. And we add together things, which this or right here is just said as or. And then the other rule we just talked about, just so you can review, is this sheet right here, where we talked about the probability of Brian and Darren getting coffee, where Brian does not influence the probability of Darren getting coffee. My brother and I don't talk to each other each morning about, do we get coffee? I drink more coffee than my brother. I have a 70% probability, and Darren has a 40% probability right there. 100 points, everyone helping out in the chat right there, dropping the game pin. Love it. Love it, love it, love it. Well, let's find out. Super Zebra, are you back, or is it Dandy Meerkat? Red Panda. They're literally Red Panda. I mean, that's a cool name right there, Red Panda. But I'm going for Quick Shark. You got to watch out for that Quick Shark right there. You got this, Ashley. Let's make it happen here with the next question. 25 questions, a few down. Here at the next question. It is, a gross jelly bean has a probability of 25%. If you eat 3 jelly beans, what's the probability they are all good? Now, this is a tougher question. So you ever have those really crazy Bean Boozled jelly beans where there's a toothpaste one, but I don't mind the toothpaste one. I'll eat a toothpaste. You say, here's a toothpaste jelly bean. I say, that's all right. I've used toothpaste every day. Why is it gross? Now you give me like the dirty diaper jelly beans or the rotten fish jelly beans. Oh my God, those jelly beans. Oh, I take one. No, that's the bad one. Okay, so what's the probability of a good jelly bean? Drop it in the chat right now if you know the probability of a good jelly bean. Who knows from looking at this right here, if the probability of a gross jelly bean is 25%, what is the probability of a good jelly bean? 75%. Bridget, great job right there. Answers in the chat. Oh no, buttered popcorn's the best. How dare you? I'm just kidding. 75%. So you eat your first jelly bean, it's good. You eat your second jelly bean, and it's good. You eat your third jelly bean, and it's good. So what's the probability your first jelly bean is good, and your second jelly bean is good, and your third jelly bean is good? Who can write it out in the chat right here as I say it? First jelly bean is good, and your second jelly bean is good, and your third jelly bean is good. See if you can solve it. First jelly bean was good, and great job, Chandler, right there. Because these are independent. The jelly beans, Rock, does your jelly beans care if they're good or bad?
It doesn't matter.
The jelly beans don't care. The first jelly bean's good, second jelly bean says, whatever. And great job for people solving it. That should mathematically solve out to probably this one. There we go. I don't know. It's not that one because that doesn't look right. 0.75 times 0.75 times 0.75. Now, this one's, I think the next one's a little bit more complicated. So listen as I walk you through it. But this was the probability. A lot of people put this answer here. This is just the probability that the jelly bean, one jelly bean is what? And he knows right there. This is the probability. And great job right there, Teresa. Excellent work. That's the probability just one jelly bean is good. Who could solve for me the probability that all 10 jelly beans, if I give you a handful of 10 jelly beans, a handful, it's going to be one handful. If I give you 10 jelly beans, what's the probability that every single jelly bean is good? If the one jelly bean has a probability of 0.75, what is the probability that the first is good, and the second is good, and the third, and the fourth, and the fifth, and sixth, and seventh, and ninth, 10th? Exactly, Chandler, right there. Just multiplying it to the 10th power. What's the probability that all 3 jelly beans are bad? Who knows how to figure out the probability that all 3 jelly beans are gross? What's the probability that each jelly bean you eat is gross? The first was gross, and the second was gross, and the third was gross. What's the probability of that? We're just doing some practice right here. Great job, Chandler, and everybody just crushing it. Jen's crushing it. Eliza crushing it. Just finished. Great job. And so these are just some practice questions. We're just trying to rapid fire and get our knowledge down. How about the leaderboard, though? No, Red Panda, no! Dynamic Sphinx, great job. This is a competitive Kahoot. Woo, who's going to win? I don't know. Let's find out. Quiz question right here. Multiple choice, you have a 80% chance of getting a question right. With 5 questions, what is the probability you get at least one wrong? So this is complicated. You have an 80% chance of getting a question correct. What is the probability you get at least one wrong? I'm going to offer you 2 scenarios, though. You either get all the questions right or you get all the questions wrong. If you write this down right here, and I'll write it down for you, all right plus or one wrong, at least one wrong, or at least one wrong, what would this equal up to? The probability you get them all right or at least one wrong would equal up to what? Oh, sorry, Mary. You'll either get them all right or you'll get at least one wrong. So you'll either get them all right or at least one wrong. That's going to happen. You're either going to get every question right or at least one of the questions wrong. What would that equal up to? You're either going to get all the questions right or at least one wrong. That'll equal up to 1. Because one of those things must happen. You're either going to get them all right or at least one wrong. So how about this? If we say we want to solve for at least one wrong, we go to at least one wrong, and it would be 1 minus all right. So if we get 1 minus all right, what's the probability of getting them all right? That's what you need to solve for. I'll write this out here in a moment. This is a tougher one. It's probably one of the toughest types of questions on the test. Take a guess if you haven't. I don't think you're penalized for guessing wrong. Let's see what people got. Matthew, kind of. You've got the probability of getting one wrong. Close, Matthew. You're on the right track. Let's see how we solve this. So when we solve this right here, let's go. Chandler got it. Chandler, great job. Excellent work, Chandler. 100 points for everybody in the chat. So let's write this out again, and let's walk through it. Okay. So a multiple choice test has an 80% probability of you getting it right. What is the probability with 5 questions? There's a character limit on Kahoot, so I have to shorten some questions. With 5 questions, you get at least 1 wrong. And this is where the experience, it's just like the light bulb problems. I was about to, NH, you couldn't have said it better. This is where the experience with these problems, having solved them on the homework, really makes it a quicker solve. Because the way we always do this is we try to write it as 2 scenarios. We write it as the scenario of you will either get all questions right, or, and that's an or right there, at least 1 wrong. Why am I putting 1 here? Can anyone explain to me why am I saying, because you take 5 questions on the test, and why am I putting 1? Here's your 5-question multiple choice question. When you see back your answers, you got this. I think Ashley might be solving it. Why am I putting 1 right here? Why is this 1? I think, well, because when you take the test, would you agree with me? When you take the test, you will either get all the questions right on the test or you'll get at least 1 wrong. Does that make sense? Does everyone follow along with that part of this? And that's exactly right there. Matthew's got it. This is everything that could occur. When you take this test, you have 5 questions on the test, and you will either get them all right or you will get at least one wrong. Like this is what you get back. The teacher says, here's your responses. You got 3 wrong. Well, you got at least 1 wrong. So you will either get everything right on the test or you will get at least 1 wrong. So if we want to figure out the probability of at least 1 wrong, we can just do some algebra on this. And the algebra would work the following way. We just now need to figure out what. What do we need to figure out now? Exactly, they're disjoint events, right? Exactly, they're disjoint. They're complement disjoint events. So we're reviewing probability. So now what do we need to figure out now if we're figuring this out? What do we need to figure out mathematically now? Because this was a tough question. These are some of the toughest ones. But if you practice them, they become like, oh, I got this. The probability of all right, Demetrius, you amazing job. And so how do we figure out the probability of getting them all right? Well, the probability of getting them all right is that you get the first one right, and you get the second one right, and the third, and the fourth, and the fifth. And we're just going to take this, and that mathematically changes into 0.85 raised to the 5th power, and that's going to be the answer right there. Does this make more sense seeing it? These are tougher questions, and I am doing like a quicker solves on these, but these are the ones that hopefully with practice, you're like, got it, solved it. Just writing it out can help. Like, I need to look at these scenarios right here. Some of the toughest questions would be these right here, but practice makes perfect on these. So check out the homeworks or the quizzes on this if you haven't, and practice, practice, practice. Let's see who's in the leaderboard right here. See who's in the lead. Great job, everybody, right there. Dynamic Sphinx leading the way. We got some easier questions coming up. Don't leave. Sometimes people leave midway through. Don't leave. Practice. Here we go. Next question coming right up. Which of the following is a rule of probability? Oh, you know this. The formula. Which formula, Jenna? Go into greater detail. Sorry. Oh, Calzone. Good to see you, Calzone. Fan favorite Calzone Tyrone here. Calzone, points for you in the chat right there. Calzone's on the lead. So which of these is a rule of probability? What does this mean? Who can explain what this means right here? Who can explain what this means? I might have to go back to the other one, Jenna, here towards the end. What does this mean right here? Probabilities are what? Probabilities are what? Like when you think about probabilities right here, probabilities will have probabilities. Just explain like, oh, any sort of probability you talk about. And then click there's an HD button down here if you haven't. Probability is always between 0 and 1. That's the first rule of probability, that probability has to be great. It has to be 0 or greater or less than 1, like 1 or less. It has to be between 0 and 100% exactly. And these other rules are rules for what? The QQ straight enough, no outliers, plot doesn't thicken. These other rules are for what? What are those other rules for the QQ straight enough, no outliers, plot doesn't thicken? And check out today's earlier video. What are the other rules for the QQ straight enough, no outliers, plot doesn't thicken? Is going to be regression right here. Great job right here. It's the QQ straight enough, no outliers, plot doesn't thicken when we're checking a regression right here. And check out those earlier videos. Evan, great job right there. And Alyssa, excellent work. So we have here rules for regression. QQ straight enough, no outliers, plot doesn't thicken. Yep, this is posted. This is posted. It'll be live later or be viewable later. With that, let's check out who's on the leaderboard now. Leaderboard is locking into place, but don't worry, there's shakeups all throughout. So I'm gonna try to post all those documents we did earlier today. You're welcome, Warren, anytime. Here we go with the next question. Let's find out who's gonna win right here. Question number 7. A researcher selects the first 20 roads next to their house. So what kind of sampling method is this? We're in chapter 10 right here. No real questions from the first test. Great question, Paris, right there. This is the chapter you want to take notes on. So we have here, is this convenience, systematic, stratified, cluster? So what is this? So stratified is when we acknowledge a difference. Cluster is when we take a groups, like randomly selected groups, and do a census on them. Systematic is every kth observation from a starting point, and convenience is selecting the easiest things to get to. So convenience, this is, because they're selecting the first 20 roads nearest to their house, that is definitely convenience. Please, if you have a question, ask it. We're doing a bunch of ones that are great note card reviews. Convenience sampling is selecting the easiest things that you can get to. So that is convenience sampling. They're selecting the roads nearest to their house. Dynamic Sphinx versus Quick Shark. Oh, Jake's throwing some big views in the chat with some Rick and Morty Vada. I'm not a big fan of the Vada Acid episode. Something Rick This Way Comes with Alan Rickman. No, not Alan Rickman. What's his name? Alfred Molina. Alfred Molina plays the devil. Yeah, if there's some Quizlets out there. I've got some Quizlets. I need to update them, though. But Something Rick This Way Comes with Alfred Molina from season 2, maybe. That's such a great episode with the devil. Here we go. A researcher selects every 5th road. Oh, I'm my Rick and Morty today. A researcher selects every 5th road on the list of roads. It's the 97 more years Szechuan sauce Rick and Morty. I totally forgot I was wearing Rick and Morty. Oh, we'll be getting to that in a second, Madison. Great question. Stratified is when you start by acknowledging a difference and then take your sample in accordance to that difference. This one right here is every 5th road from a random starting point, technically. Oh, that'd be good. I need to make some memes with Mr. Meeseeks. Actually, I have. Where's my Mr. Meeseeks picture? Where did I go? He's in the other room. I got a Mr. Meeseeks picture somewhere. Oh, he's over there. I got a Mr. Meeseeks. Right. I'll show it to you next thing. With this right here, this is every Kate observation being selected. If you want to drop some Quizlets in the chat, you're more than welcome to drop. Make sure it's a link from mods. Make sure it's a link from mods. Well, I think only mods can drop links. Demetrius. Oh, that's Demetrius. 100 points, Demetrius. Thank you so much. Helping out. Vols help Vols right there. Demetrius, thank you so much. Let's go check out the next question. Here we go. It's Dynamic Sphinx versus Quick Shark in the chat right here. Let's see. And remember, please email me if you win. Send me a screenshot of your win. Let's do this. A researcher lists all roads and randomizes the order and then selects the first 50 roads. Ooh, so selecting the first 50. They're randomizing all the roads and randomizes the order and then selects the first 50 after it's been randomized. The researcher takes the list of roads they have access to, randomizes the order, and then selects the first 50 roads. So what would this be? Now, a lot of people... Hopefully not a lot. Hopefully not a lot. We put this on a test one time and it caught a lot of people. People might think it's convenience, but it's not. Oh, people thought it was cluster and stratified. So what is the... we'll show the notes right here. What is the key characteristic of a system of a simple random sample? What is the characteristic of simple random sample? Going over here to these notes. Simple random sample has what? And we reviewed this earlier. Check out today's earlier video for more in-depth reviews. Systematic sample, simple sample, oh my gosh. Simple random sample right here is when everything gets a number and then you select numbers randomly. So in a simple random sample, think of like ping pong balls. Ever seen the ping pong ball thing where you just circle, you take the ping pong balls and you take one out? That is the idea of a simple random sample, that everything has an equal and likely chance of being selected. When you think of systematic, you're thinking of every kth observation from a random starting point. Where the confusion usually begins is when we go down here to stratified and clustering. What must we do? And this is a big review. I'm going to try to get some good answers to the next few coming up questions. When we do stratified, what do we always do when we do stratified? What do you always do when you do stratified? You always do this to start with stratification. You can see the answers at the top of the screen. I can say it, but I want you to say it so you can practice it. What do you always do? Marjorie's got it right there for some 50 points in the chat. You're always going to acknowledge a difference. You're always going to acknowledge a difference. You're going to have a difference that you acknowledge, and then you're going to randomly sample according to those differences. So notice here that we have on-campus versus off-campus students. So now we want to sample 200 students, and 40% of students are on campus. So we would sample 80 on-campus students. When you do clustering, how are the groups assigned in clusters? How are the groups assigned in clusters? How are the groups assigned in clusters? If you have clusters, the clusters would be whatly assigned. This is the practice. When you have clusters, you have random assignment of the groups. So tell me this, if we went into UT dining halls like Student Union and we talked to 50 tables of students, We are assuming that those tables are randomly assigned. And then we are going to take those tables and talk to how many students at those tables. When I walk up to a table of students and say I'm doing a survey, I'm going to talk to how many students at those tables. How many students will I talk to at the table when I do a cluster sample? So simple random sample is just when you take individuals. So the clusters are basically like large groups. Kylie, great question right there. In the cluster, you're going to take like the table instead of taking one student. Demetrius, you are correct. Demetrius said all of them and do a census. Correct. You're going to talk to everyone at that table. So it kind of works like this. I'll draw a difference down here. If you're doing a simple random sample, you would want to talk to just random students. We'll just take this student right here, just A+ drawing skills in Stat 201. And so we're just going to take and talk to random students right here. We just got a whole bunch, and then we're just going to sample students randomly. Does that make sense? But when you do cluster sampling, you now have something like tables of students. So now we just have random tables of students. And so now, I am artiste. So now with this table of students, we are taking random tables of students. So does that make a sense of what the difference here when we do a simple random sample? And when we do cluster, it might not say cluster, but the clusters are the tables. And so this is a random group of students. It's a cluster of students. Where over here, we would just take random individual students. Does this make more sense with the A+ drawings here? Is that we have a cluster of students over here where we would sample a whole table, but over here, we would sample just like one individual student. Here, we would take clusters of students at one time and talk to everybody at the table. So the table is a cluster of students. And remember, every table of students is thought to be a what group of students? Every table of students is thought to be a what group of students? Like, oh, I'll just go to a table of students. It's thought to be a what group of students? You're not acknowledging any differences here. You're just saying, let's go to a table of students. What do you think clustering can be used for? It helps you get a whole bunch of samples at one time. So when we cluster, and so stratification immediately starts with differences. So we could have tables of students in different dining halls. And as soon as I say, let's talk to maybe 40% from like West Campus and 60% from East Campus. I don't even know if that's how we divide up campus. I'm starting to do a what if I say like, let's talk to 40% West and 60% East Campus. By saying we need to sample according to this, I'm starting to do a what, which we could do a multi-stage here. But by saying we need to talk to this percent this because this is what people see that people use, I'm doing a stratification. I'm saying we should go to maybe like 40% dining halls on West Campus, 60% on East Campus. So now we're saying take from this group this much, this group from this much. We're acknowledging a difference between the groups. So we could still take tables. The tables would be the clusters, and then going to a certain side of campus would be going to stratify it. Stratifying always acknowledges a difference to start, and then samples within those differences a certain amount. What will we not do? We will not talk to everybody on West Campus. We're not going to go to West Campus and talk to everybody. You don't take all of a strata. Please write, I want to see that in the chat, 100 points. You don't take all of a strata. And I'll repeat that when we do some of these practice questions coming up. You don't take all of a strata. You don't go to a strata and say, let me talk to all on-campus students. No, that's how clustering works. Clustering talks all people at a table, or like all people, you know, maybe walking out of a restaurant so we could take a cluster at that restaurant. You don't talk to all people, all things in a strata. You don't take all the sample of a strata. You don't go to a strata and say, let me talk to all on-campus students, because that would not be representative. Great job right there, Sophie and Teresa and everybody. Excellent work. Let's see who's in the lead. Huge shakeup of the leaderboard. Absolutely love it. Huge shakeup right here. Quick Shark. Who's going to win? Next question coming up. A researcher selects their sample based on the percent of highway, country roads, city roads. Basically, you know, acknowledging a difference. You know, they're going to take a certain amount of country roads, a certain amount of city roads, and a certain amount of highway roads. So they're like, okay, Knoxville is composed of 50% highways, 30% country, and 20% city. So I need to make sure I'm representing these groups. So I need to, you know, go and take like 30 miles of highway roads, 20 miles of country roads, and 10 miles of city roads. Math didn't work out quite the same. Ah. Oh, yeah, I see. Thank you. Thank you. We tricked 8 people. That was not our goal. I put this acknowledging a difference. Do you see how they're acknowledging a difference right here? Sorry, Marjorie. Does it make sense? Country roads, take me home. 50 points right there in the chat. Does this make sense how we're acknowledging a difference between these? Like, would you agree highway roads, country roads, and city roads are different, and we are not taking all highway roads? We are going to take a percentage of highway roads, a percentage of country roads, and a percentage of city roads to be representative of the roads in Knoxville. Who's winning? I'm putting my vote on Radiant Griffin. Radiant Griffin, you got this. Make this happen, Radiant Griffin. Here we go with the next question. Our researchers decided to take 5-mile segments of roads and sample 1-mile segments from within. They're performing a census on that 5-mile segment. So they're taking like a 5-mile segment of once from an area, and then they're doing like looking at within those 1 miles. They're saying, okay, that's a sample of 5. That 5 mile just taken at random. They're just taking a bunch of 5-mile segments. Are you quick, Shark? And so they're taking these 5-mile segments and sampling 1-mile segments within. So it's a bunch. They're taking a bunch at once. Just 5-mile segments. No differences acknowledged. Wink, wink. This would definitely be clustering. Definitely clustering. So I think the 5 caught people off guard right here, but this does not say every what mile. If it was systematic, it would say every, like, they go and take every what mile. Like, change this to a systematic question, like researchers go out, they're driving on the road, and they decide to take every blank, like change it to like a more of a systematic sample. Like from a random starting point, the researchers go out and select every what mile. So what would that be if it was systematic? We try to, if there's a decent wrong answer with some answers, we try to then point out how it could be that. Every 10th mile, every 5th mile, every 20th, there would need to be like a 5th up here. Does that make sense? Oh, no, that's fine. Mary, you got it. 50 points right there. It would be just every 5th or something like that. Want to rematch Vincent? Every 5th mile or something like that to be systematic. Systematic has every kth element to it, and knowing the differences right here are key. So practice, practice, practice. Oh, did I forget to close the poll? What? 100 points right there, Marjorie. You are correct. Zaxby's won. Go get some Zaxby's tonight. Radiant Griffin. Right now I have a feeling about Majestic Elk. Majestic Elk, you got this. Let's make this happen with the next question right here. The question is, the researcher takes too many city roads in their sample. They're taking too much. What bias have they run into? They take too many city roads. What bias are they running into? Do you know the bias of the too many? Now, this is weird. Oh, great job there, Lauren. Now, we don't have a bias that we talk about with too many. People might be like, wait, too many? I thought it was that. Well, if you have too many of something, you also have too few of something. So I think that often confuses people. If you get too many city roads, you would undercover other roads. So undercoverage bias right here, we had a bunch on response bias. I don't know if the roads could really give response bias. Good answers, everybody. 50 points. Don't worry if you got it wrong. Response bias is going to be something like, it's easier when you ask people questions. I'm going to come up with a different response bias question. Like, let me ask you this question. Do you, lately, UT has had limited parking spaces for students on and off campus. Do you think UT should increase the amount of available parking spaces on campus by opening up lots more? I don't know. What I did there at the start puts response bias in there because Troopsy says yes right there. Oh, you just get the points. I click the point button, you get points. People can show you how many points they have at any time. But you can check your points. But response bias is when the way the researcher asks the questions or the way they word it puts bias in the response. Does that make sense what response bias is? It's the way in which the question is worded, the way in which people might, like one of my favorite questions, which I've asked 1,000 times is like, do you think it's fair that you can get married at 18, but you can't drink a beer? That's the real question is, should the drinking age be 18? Asking someone, do you think it's fair you can get married at 18 and you can't drink a beer? That's not really the way we go about doing surveys. That's putting a bias that someone's gonna be like, yeah, it's not fair. And you're like, oh, do you think we should lower the drinking age? You're like, yeah, I think we should lower the drinking age. You should just ask people, should the drinking age be 18? You don't try to push views into questions, which creates a response bias. Undercoverage bias is when you, like other examples I talk about is like you go to the college libertarians and you say, who are you voting for? And they give you views of themselves because you're going to undercover other groups on campus. If you want to get the views of who people would vote for on campus, you want to be representative of all students, and going to one specific group would undercover other groups right there. Convenience bias is when we select the what's individuals. Great question, NHA. Let's throw some 50 points. Thank you for asking that. What is convenient bias? And then we'll cover the last one here. What is convenience bias? Someone put some definitions in the chat. Remember, it's better if you practice it than me, because you're going to have to know this for the test. Convenience bias, Brian doesn't know it. I don't know it. I forgot it. You got to help me out here. We had a question earlier on it. Convenience bias is when you do what? Generally speaking, we select the what individuals. Think of what the name of the thing means. Taking what is most convenient, the easiest, the first 100. Great job right there, Dan Nav. Taking the ones that are easiest to get to, putting your survey online, the ones, you wake up in the morning, talk to the first 50 people you see. That's not going to be representative. It's going to be convenient. Lazy sampling. I like that right there, Benjamin. Great answer. Lazy sampling. The easiest way of doing it. It's not going to be representative. Great answers. The last one we have here is non-response. Non-response is when people who don't respond differ in the ways than those who do respond. It's kind of a little bit like voluntary bias. We were talking about that during the review earlier. But non-response generally occurs if you ask like controversial questions. People might just be like, I don't want to take part in your survey about politics. Politics is controversial in some ways. And so the people who don't want to respond may have views different than those who do respond. So people opting out of taking your survey is non-response. They're not responding. So I like a lot of these. They pretty much are what they say they are. Good way to memorize them right there. Let's see who's in the lead on the leaderboard. Ooh, shake up of the leaderboard. I should have bet on Brave Raven. Brave Raven, you got this. Let's make this happen here with the next question. The researcher collects roads near their house. Researcher collects roads near their house. Wow, Brian. Researcher collects roads near their house. I am hoping never change something before you're about to do it. Please don't be wrong. Please be a repeat. Woo! Got scared there. Researcher collects roads near their house. Brian can't math or English. 100 points right there. Mary. Mary knows Brian can't math or English. Researcher collects roads near their house. Don't ever change things right before you're about to do it. Let's see who's in the lead here. I told you, Brave Raven. I was putting all my votes into Brave Raven, and see what happened right there. Brave Raven, you got this. You should see my road collection. Oh, man. That's awesome, Matt. Matthew. Next question. The list of roads that the researcher has access to sample. Oh, grammar's back. The roads we have access to sample. So this is pretty much definitionally what it is. The things that we have access to sample. So think about, what does it mean, or what are we talking about if we have access to sample something? Now, these are not the ones we sample. This is not our sample. It's not what we sample. It's not what we want to understand. So you're down to 2 right now. You should have it narrowed down to 2 right here. This is what they have access to sample. And what they have access to sample is the sample frame. The sample frame. One of my favorite things to talk about is if you go to the library at 2 a.m., what would be the sample frame? This is one we should have down right now. If you go to the library at 2 a.m., what is your sample frame? Explain to me. You want to talk to students about their study habits. You go to the library at 2 a.m., what's your sample frame? Kind of, Marjorie, you are correct. Kayla going more exact right there. That is, Marjorie is correct. So I think Marjorie, you're saying that. And then Kayla said, everyone at the library at 2 a.m. Because now, does that mean you're going to speak to everybody? Does that mean you're going to speak to everybody at the library at 2 a.m.? Are you going to speak to all of them? Does that what you're saying is? Procrastinate. Is that really the procrastinator, Jack? No. Those are just the people what? The people at the library at 2 a.m., because you're going to take your survey then, are the people you what? Those are the people you have what? Explain to me. If you go to the library at 2 a.m. to talk to people, the people at the library at 2 a.m. are the people you what? It would depend. The people at the library at 2 a.m. are the ones you have access to talk to. You could theoretically talk to them. Does that make sense what a sample frame is? It's the theoretical people you could talk to. So we might ask a lot of times, is our sample frame representative? So the sample frame is theoretical. You're not going to speak to everybody. You might speak to everybody at the library at 2 a.m. You could, but the ones at the library at 2 a.m. are the ones you could theoretically speak to. The ones who do talk to you would be your what? The ones who do talk to you would be your what? The students who do talk to you, the ones who say, oh yeah, I'll take your survey. The ones who do talk to you will be your sample. The ones who do talk to you would be your sample. The students you could talk to would be this. Students you want to understand would be this. And what you want to understand about them is the parameter of interest. Next question, who's in the lead? 100 points. Thank you, everybody right here. Following along, practicing. It helps when you put those answers in the chat right here. Guys are killing me in the chat. But no, who's doing amazing now right here? Brave Raven. Brave Raven. Sounds like Teen Titan name right there, Brave Raven. Let's find out who's going to win right here with the next question. The road that the researcher samples. Not a trick question. Not a trick question. Not a trick question. Maybe some tougher questions coming up. Not meant to be tricks. I don't put any real trick questions on these, but there are questions that people miss. The roads that the researcher sample. Where we're going, we don't need roads. What are the roads that the researcher samples? I know, right, Matthew? That is the... Woo! I'd love it if we got 100%. They changed the way this looks nowadays. They changed it. They changed the way that looks. They updated it. I know it doesn't really sound like interesting research. I agree with Kelsey right there for 50 points. This is who I will be for Halloween. I have no idea who you're going to be for Halloween. Let's find out the next question right here. Who's in the lead? Ooh, leaderboard's locked up. Next question coming right up. Here we go. Get ready. The researcher, what the roads the researcher wants to understand. Not a trick question again. These are easier questions. These are definitions we've gone over. I'll give 1,000 points if we have 100%. That's a mean thing for me to say, though, Jace, because I've rarely seen it with this many people. If it happens, I'd give 100,000 points for fun. I'll give some more points at the end of the Kahoot, stay till the end. But, man, yeah, I wish we'd get everyone. I have no idea. Oh, no! 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 The roads the researcher wants to understand. That's not 100%. Oh, it's a Raven. Or the Raven from Teen Titans. The roads the researcher wants to understand. Now, the last one was the roads that the researcher sampled. The roads that the researcher samples is the sample. So when we talk about the population, so Tanya, great question right there. The population is what, like the group you want to understand, and then the parameter of interest is the what. Who can explain what a parameter of interest is? Who can explain what a parameter of interest is? This is good review right here. Who can explain what a parameter of interest is? We got to pause when we get stuff wrong. A parameter of interest is what? A parameter of interest, the what they want to understand, exactly like the characteristic of it. So what you want to learn about it, the truth we're trying to understand. Great way of putting it right there. So with this right here, if they are trying to understand something like potholes and how many potholes there are, that would be the parameter of interest. If you go to students in the library and you want to know how many hours they spend studying, what would be the population? Now be very careful. You go to students in the library and want to understand how many hours they study a semester, what would be the population? The population is the group you want to understand. It's the what you want to understand. UT students. Explain to me the parameter of interest. The parameter of interest is the characteristic that might help people, like a certain quality about it that you're trying to understand. It's when we say population parameter of interest, the parameter of interest is now a quality about the population. Like how many hours do UT students study is the parameter of interest. So what would we do? We'd take a sample of UT students, and from that sample, we would get a what for how many hours students study. This is kind of the key words that we were practicing earlier. From a sample, we would get a what for how many hours students study, which is an estimate of the truth. From a sample, we would find out another S word. From a sample, we would find out a statistic. Marjorie, you got it right there. We'd find out a statistic, which would then help us understand an estimate of how much students study. You're like, I want to figure out how much students study, so I'm going to take a sample and try to estimate from my sample the truth for a population. This statistic that I calculate will be an estimate of the truth for how much students study. So roads of the population, The number of potholes would be the parameter of interest. Sample is the roads that we take, and the sample frame is the roads we have access to sample. Does that make sense? Let me repeat that, Matthew, again. Great. And Matthew, thank you so much for writing that right there. Roads in Knoxville are the population. All the roads in Knoxville. The number of potholes per mile would be the parameter of interest because we want to understand like how many potholes there are on the roads. The sample would be the roads that we take data on, that the researcher collects data on. And then the sample frame would be all the roads we could possibly get to. So we might not sample everything, but we might have all these roads that we could possibly go to collect data on. So the roads we could theoretically go to are the sample frame. The roads we collect data on are the sample. Yeah, it's good review right here. Thank you, Matthew. Another 100 points, Matthew. Keep it up. And amazing questions, Matthew. Just keep asking those questions. Here we go with the next one. Let's do it. Oh my gosh, we're Brave Raven's still there. Brave Raven's still there, but Melodic Stork in the lead right here. Can't sample all the roads if they block by a tree. Exactly. Next question right here. The researcher wants to understand the average amount of potholes per mile for all the roads in Knoxville. So the researcher wants to understand the average amount of potholes per mile. This is what they want to understand. Game pin right there, Zaid. Hop on in. 386679. They want to understand the average amount of potholes per mile. So what is this going to be right here? The average amount of potholes per mile is going to be the what? I'm not blocking a right answer. This is the characteristic of the population they want to understand. Yeah, Matthew, like good review, right? Can we get that 100%? Let's make it happen. Come on. Oh, I like that. You know what? I'll throw you 500 points. Great job, everyone, following along. We were just kind of giving away the answer to this. I'll throw some 500 points in the chat. Let's make 100% happen, though. I'll drop some hints to some questions. You got this. So that is the characteristic of the population they want to understand. They want to understand all roads, which is the population. And then the what that they want to understand about the roads is the parameter of interest right there. Everyone earning some points. Isaac, great job right there. Here we are with the next question. Earn up those levels. So, my brain's breaking. Melodic Stork still in the lead. Brave Raven, catch up though. You got this, Brave Raven. No pressure, you got this though. Next question, here we are. Probability of making a shot, what is the complement? Ooh, quick question. Who can get this really quickly? The probability of making a shot is 30%. What is the complement? Now, this one works really well for like P and Q stuff because P and Q are complements of each other. So whenever you're finding P, if the probability of making a shot is 30%, complement is always 1 minus. Really quick question right here. You got this. Just like, boom. And do stay after if you want. You could win, the 320 Kahoot. You never know. The complement is good shot. I don't get it, Matthew. You have to tell me how that joke works. Oh, why didn't we get 100%? This was our one, right, Jace? This was our... No. There'll be some more points at the end, but that was our shot. That was our shot. Got one shot. Can't stop. Oh, man. Okay, so compliment is just 1 minus. Here we go with some more. So close. Rip our chance at 1,000 points. You never know. We can make it. Let's make it happen. The law of averages is a fallacy. The truth is what? Ooh, a lot going on right here. So one of these is a true statement right here. Is the true statement if heads occurs too much, tails is more likely? Does a coin really care? No. 2 disjoints can be easily added together. Well, that is true. 2 independent events can be easily multiplied together. Well, that's true also. Past events do not influence independent trials. The law of averages says that if something does not occur after a while, it'll be more likely to occur. But actually, past events do not influence independent trials. So, I bet some people lagged. Oh no, yeah, I think you might be right. Jen's right there. It's a bummer. We lose about half the people during Kahoot, but still, it's just time for fun, time for practice. And what is the actual law of averages is a fallacy? Does anyone remember for the other 500 points? I'll tell you the other 500 points. What is the law that states over repeated trials of something, over repeated independent trials of like flipping a coin, you'll see 50% heads. If a coin is truly fair, you will see the true probability. You got it right there, Jen's earning everyone another 500 points. I told you I'd throw some big points out. Let's make it happen. Here's the 500 points. Let's have in special guest host.
Newbot? Newbot is here for special guest host. Who's gonna win? Ooh, Majestic Elk? Great job. Here we go. Next question. Let's do this. Points or bonuses in Brian's classes. We knew UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is N? Oh, you got this. What is N? Who knows what sample size is?
Bebop, go away. N is sample size. It's important to know your notation right here. So you need to identify, we know UT is 20% freshman, and this will be used for more questions. We know UT is 20% freshman. We sample 200 students, 30 report being freshmen. Oh, this is the one. Is it Kayla? Oh, man. I told you it's hard to get that 100%. I tell you, I've done these a lot. I tell you, it's hard to get that 100%. Okay, let's. You got kicked out. Oh, no. Why is it kicking? No, we won't use the subtract right there. That's some Streamlabs. If we know UT is 20% freshman, let's help out. Let's kind of do a little Salt Bay here of the questions. You ready? If we know UT is 20% freshman, what have I just told you? If I know UT is 20% freshman, it might not be. Let's pretend for a moment. A code right behind me. We know UT is 20% freshman. Oh, Daniel, thank you so much. 100 points, Daniel, giving some positivity right there. If I told you, Zaid's got it right there. So this is the truth, which will be, it kind of will be something for that for later on. Let me show some of the notes for this. We were going over this earlier today, so please check out some of the reviews we did earlier today on this being P right here, which is the mean for the distribution of the sample proportion. That is the mean for the distribution of sample proportion, but I wouldn't call it the mean yet. I wouldn't call this the mean. This is the what? Tell me in words. People are correct. That is the truth. But if we know UT is 20% freshman, then that's going to be what? You are correct. It is the truth. It is the mean for the distribution of the sample proportion. It is the what, though? And it is a population parameter. That is true also. It is the what proportion, though? It is population parameter, and it is, which all these, like everyone's basically getting correct. It is the true proportion. Does that make sense? Which is P. P is the true proportion for the population, or the true population proportion. It is P. All these things here are correct. We're kind of salting the mind for some later answers, so get ready to do some of these questions. Now, here's when people get wrong. 30 of the 200 freshmen, 30 of the 200 students report being freshmen. So what is 30 in notation? 30 of the 200. 30 of the 200. 30 of the 200. 30 out of 200. Demetrius right there, amazing job. That your Quizlet must be really good because you've got this down, Demetrius. That is X, which is the number of successes. Then what can we use 30 to get? 30 out of the 200 is going to give us what? Like I've just calculated what right here. 30 out of the 200 can be used to calculate what? X over N. That's X over N is being used to calculate P hat, which is the sample proportion. That is from a sample, the proportion. Notice how P is the true proportion and P hat is the sample proportion, or observed. Great job right there, Mary, another 50 points, which is what we observe in a sample, not the truth actual. Great job, everybody. We salted the mind with some answers right there. Let's go ahead and check this out. Ooh, who's going to win? I don't know. Let's check it out with the next question. Here we are. We know UT is 20% freshman. We sample 200 students and 30 report being freshmen. What is P? What is P, which is the true proportion? What is the true proportion of freshmen? We know UT is 20% freshman. We sample 200 students and 30 report being freshmen. What is P? I guess another announcement, Daniel. Hopefully we have a bunch of people for 320. We'll do 320 next. What is the true proportion? When you see what is P here. Does anyone know what Q is? Anyone know what Q is? Oh, jeez. Does P not equal mu? Well, it's the mean for the distribution of the sample proportion. It's going to be, that is correct, right? That's 20% right there. We know it's 20% freshman. So this is the truth right here. We know UT is 20% freshman. And that is the mean for the distribution of the sample proportion. When you call it the mean, you just have to be very careful because it is the mean for the distribution of the sample proportion. So it is true that whatever P is, you see how P is 70% here and it's 70% here, but we don't think of P as the mean. P is the true proportion, and the true proportion is the mean for the distribution of the sample proportion. You are correct. It's kind of the mean, but don't just think of P as the mean because then you might think of it as quantitative. These questions here all are what kind of questions? When we're dealing with the distribution of the sample proportion, every question right here is for a what kind of variable because we're asking people if they're in state or out of state. These questions right here are for what? If it's categorical, right? So this is like the proportion of students who are in state. Very important right here. Check out the reviews from earlier. A lot of review, a lot of practice to make sure we have these down. Next thing, let's find out who's winning. It's a tight leaderboard. Next question. Have your calculators ready. Who's got their calculator out? I'm putting 30 seconds on the clock right now. And we're playing a tiny bit of music. Get those calculators out because you need them. Should have said that at the start. Because there were some questions with the calculators earlier on. You voting for Quick Shark? Get those calculators out. While you're doing this right here, I might send out a quick announcement. I'm going to send out a quick announcement to... Oh, man, we got 100 people watching. That's awesome. And let me send this out to 320. Have your calculators out. Review's about to be over. Let's say Kahoot starting. Starting in 8 minutes. See you soon. Click here. About to hear Brian doubling up on his voice. Here we go. Kahoot starting in 8 minutes. And there we go. Got that. Sending out to all sections. Announcement sent. Let's do this. Quick Shark is Terry Higgins. Terry, you can't win all the prizes, man. Let's find out who's going to win here. Next question coming up right here. Let's do it. UT is 20% juniors. 80% of students are 80 students selected. 30 are juniors. Find the mean of the sampling distribution. That's all we need to know. Find the mean of the sampling distribution. Find the mean of the sampling distribution. The review from earlier is posted, Catherine. Yep. Find the mean of the sampling distribution. So mu p hat equals p. Remember, mu p hat equals p. So what is p? The mean for the distribution of sample proportion is the mean. This is mu p hat equals p. Mu p hat equals p. Once again, we know that UT is 20% juniors. If UT is 20% juniors, then we would have mu p hat equals to p. So we just know p right here. You're told it in the problem is 20%. Oh no, N8, you got this. You got this. Let's do the next question here. Leaderboard's locked. Leaderboard's locked. Remember, we're not here to win. We're here to practice. I don't know how to respond to that, Kale. I don't know how to respond. All right, here we go. You ready for the next question? Everyone get ready. All right, next question coming up here. Does that need to be a quote? Let's put that as a quote right here. We'll put that as a quote at the end of the Kahoot. You ready? 3, 2, 1. Next question. Here we go. We know UT is 20% freshmen. We sampled 200 students, 30 report being freshmen. What is P hat? You got this. You got this right now. Let me get Mubot with the quote. All right. I'm putting the quotes in. This is officially quote 112. Official quote 112. Oh, that's quote wrong quote. He doesn't know that quote yet. Oh, man. Quote 112 forever right there. Everyone will always remember that. Quote 112. Oh, too funny. Okay, so how do we get p hat right here? Can anyone put the formula for p hat, and what do we need to identify this? Some people put p right here. This is p, which is the true proportion. I'm trying to hammer down. How do we solve for p hat? Great job. 100 points. Lasia, see in the chat right there, people are saying x over n, and then people are putting x is 30 right here. This is p hat means sample proportion. So we need to look at how many students were sampled, and then we need to see 30 out of the 200 were freshmen. So the sample proportion is going to be 30 divided by 200. Does that make sense? Lasia, thank you so much for asking that. Lasia, I want everyone to say thank you right here in the chat, because I'm throwing out the 1,000 points, 1,000 random points, because I want to point something out. There's people losing right now who have left, but there's people here for knowledge. And if you're here for knowledge, you're winning. We're all winners when we're here for knowledge. So I want you to keep asking those questions. So when you have a question, ask it. That's how we learn. That's how we win. If you don't win this Kahoot, don't worry. There's going to be 3 winners. Don't worry if it's not you. So let's make this happen. Let's win some more points, and let's learn some knowledge. Here we go with the next part right here. Crazy points. I told you there would be crazy points, but you didn't believe me. I was losing, winning on loop. Ashley's spirits have been lifted, but you know who's got their points lifted right here is Melodic Store, Quick Shark, and Radiant Griffin. Let's find out. Oh, let's go to the next question right here. Oh, man. Ashley's killing me. Next question coming right up. Here we go. UT is 20% juniors from 80 students, 30 are juniors. Find the standard deviation of the sampling distribution. Ooh, you've got that calculator question. Multiple choice, but can you do it with the calculator? Now, I'd narrow this down to probably 2 answers right here pretty quickly. But then you're stuck. You got a 50-50 shot. This right here is going to be P. This is Q. You probably want to know what N is. And they probably want to do a little P times Q over N square root. P times Q over N square root. P times Q over N square root. Brian's on a sugar high. Some awesome ice cream right here. I think it's HEB flavored ice cream, not HEB flavored. That's not HEB. I don't know who makes it. It's called Love at First Swoon. Mind your P's and Q's. Know your P's and Q's. Where P is the true proportion, Q is the complement of the true proportion, 1 minus P. So it should be 0.2 times 0.8 over, the Boole equations be given. That is correct. And do check out the review sheet right here. I'll solve this in a second with P times Q over N square root. You do have the formulas. You can print it out. Here, we'll show this real quick. That's not good. Here we go. Let's go look at the formula sheet right here. The formula that we are looking for is P times Q over N square root. So if you remember from our problem, can anyone remind me what P is? Wrong thing. Can you remind me what P is? What was P? What is P hat not provided on the formula sheet? X over N. X over N, Michael. Great question right there, Michael. P is 0.2. That means Q is the other side of it, which is 0.8. It's just 1 minus P. P times Q, and I think N was 80, and then quantity square root, and that rounds to 0.045. The true proportion, exactly. You can print it off. You want to either print this off or write it down and show it at the start of your test. Someone said this didn't copy. That's all right. Just make sure to show this at the start of the test. Be like, here is my formula sheet, start of the test. You'll do a room scan this time. So we do have the room scan enabled. Just make sure to do it. And if you have problems or questions, contact us immediately. Got to make sure I got our announcer ready for the finals right here. Don't want to close out of the Kahoot. I'm just not even going to mess with it. If I close out of the Kahoot, that'd be very bad. Let's go on. I think we're on to the last question right here, right? Holy mackerel, what just happened right there? Speedy Wildcat, this is absolute insanity right here. It's anyone's game. I try to tell people that at all times. Let's get ready here for the next question. Here we go. Everyone ready? I need some I'm-rays in the chat. We're going to play some awesome anime music right here. I need some I'm-rays in the chat. Let's make this happen right here. Here we go. Last question of the night. Let's make this happen here on Stat 201. I'm raising the chat. Here we go. For the sampling distribution of the sample proportion, what is the third condition? The sampling distribution of the sample proportion. Well, the first condition is always random. The second condition is always 10%. Now, you always pause when you get to the third condition. Right now, you're thinking between the large enough n, which is for a certain type of variable, or if it's success failure, which is for another type of variable. Remember, random, condition 1. Less than 10% of the population is sampled, condition 2. And then you're stuck. What we see here is proportions, and proportions means it's categorical. And categorical means it's going to be success, failure. This is a big thing right here. What do? We always pause in the chat right there. Love it, Nate. Pause in the chat. But you know what it means. Everyone knows who's going to be here for the very end.
Tiny Brian. Hey, everybody. Time for you to see who won. I'm Tiny Brian. Third place. I don't know. Or, whoa, 20. Brave Raven. Yeah, Brave Raven. Second place. Melodic Store. 24. No one got everything. It'd be large enough and Quick Shark. Yeah. Great job, everybody. Oh, my parrot. Oh, what up, Burb? Burb's the word. Burb's the word. Where's my tiny parrot? He's a good guy. Tiny Brown. Where's my tiny puppet shark at? Tiny puppet shark? Yeah. Thank you. That's a big puppet shark. Woo! Tiny Brown, away. Wait, I didn't go.
You're welcome. Hope everyone had a great time tonight. We're going to start the 320 review. You're more than welcome to stay for the 320 review. How do we get them? Oh, yes. Email me, send me a screenshot of it and say I won the Kahoot or first, second, third place. I'll send you the Amazon gift card. Tell me an email address you prefer to be sent to. What time is the test on Wednesday night? Still 7:30, I believe. Double check. But the exam should be same time as last time. Please contact me if your exam time has not been changed or you've not had any SDS accommodations put on there. You're welcome, Ashley. Thank you, everybody, for showing up and being here. Glad these help out. Good reviews. And just remember, biggest thing, and I want to say this, how many questions? Like 40, 45-ish questions, about the same. Usually our tests are usually above similar format. I want to say this big thing right here. We'll head over to the main screen here, and we'll play a little chill music. Let's head over to the main screen and then get ready for the next Kahoot. You kill me, Nate. Kill me, man. You kill me, Smalls. Thank you, Jack. The biggest thing is divide up your time reviewing into little bits. Try doing like 40 minutes of review, 20-minute break. 40-minute review, 20-minute break. And, you could have chill music on like this. Like, I put on music to just chill and, like, meditate, like, to just, like, clear my mind. The more focused you are on reviewing, the more you get out of it. And then you don't want to sit down and say, I'm going to review all day. I've had too many students who tell me, I stayed up all night reviewing and I failed the test. Well, your brain just doesn't like that. I'm one to talk. I used to do it all the time, too. I didn't make the best of grades. But then when I learned, especially my fiance was like, hey, you go 40 minutes and then we play some Mario Kart. You go another 40 minutes and you play some Mario Kart again. And you can actually focus and your brain can give that attention span it needs. And people have told me what method it is. What chapters are on the exam? It goes from regression all the way. Tomorrow we might actually do slightly new material that's going to converge. I'm going to move around assignments a little bit. And then Wednesday we'll review. Tomorrow I'm going to kind of use it as a bridge class. To talk about confidence intervals and what we should know. And then I'm going to move the assignments. I have to remove around assignments. Wednesday is definitely reviewing. I mean, day of test, you got to review. Reward the brain for studying. Yep. You have to take some time to be like, you can't study for 10 hours straight. Your brain just says no. Oh, all those difficult questions. Let's go here. So please email me one. So the review before this was linear regression. We did linear. Yep, we did. So there was no linear regression on this, but we did linear regression earlier today. So check that out, Demetrius. Who's my main? Samus. My main is Samus in Smash. Gotta go with Samus or Pikachu. Original Smash Pikachu. Smash Melee is the second one, right? Melee Brawl Ultimate. I don't play much Ultimate. Ultimate's bad. Don't play Ultimate. We're gonna pull up the 320 review. I tell you, you might think I'm crazy. There's so much. Am I wrong? For those who play Smash, is there more latency? Is there more latency on it on Smash Ultimate? I swear there's latency. I go and I click my button, and my Samus does not do her punch, and I'm like, this is nonsense. I can't play this game. Button lag. I know I'm good at Smash. No, I'm not like the best in the world at Smash, but we used to play Smash, like, it came out, like, original Smash came out in, like, 01. No items, Fox, only Final Destination. Oh, yeah, everyone plays Final Destination. Yeah, no, Jack's right there. I'll play you no items against Fox, Final Destination versus Samus. Fox always doing, like, his reflect thing, shooting my blast at you. That's because Samus is mid. Samus is what I don't know enough about Smash to have enough good enough gaming chair. It's probably my gaming chair, you're right. Electronics repair text here. The Switch has more mechanical failures than previous controls. Yeah. No, and also there's drift. And I'm not even making that up. People, if anyone has a Nintendo Switch, they know there's drift on those controllers. Absolutely drives me nuts. I was like on a plane ride and my character's just like slowly walking in one direction, and I'm like, psh. Yeah, Joy-Con drift is ridiculous. Come on, Nintendo. And then is there going to be Joy-Con? Is it on the new OLED? And then if you get the Switch like lights or whatever, Switch lights, the controls are hard coded in. Yeah, that doesn't shock me. I've seen ways to fix it, but I use Pro controllers. Do Pro controllers have drift? I think the Pro controllers have drift too. Yeah, I've got Pro controllers. Like, I literally bought my Switch and brought Pro controllers like first thing about 2 Pro controllers. So I was like, and then I got the Smash bundle and got the Pro Smash bundle. We're gonna start up the 320 review here in a second. Brian, you got Brian talking about video games. Yeah, you got to play with a Wavebird. Yeah, play with a Wavebird. That's where it's at. I have 4 wave birds. I mean, you gotta. If you're really playing Smash with your friends, you got 4 wave birds. You don't got the cords running around. One of your friends gets that Mad Catz controller, they're gonna lose. You're playing with a Mad Catz controller, you're gonna lose. You can buy this adapter where you can use different. Yeah, I think I've seen that. I should use that. Peace. See it. Good to see you, Jake. We'll start up the new Kahoot. Here's the new Kahoot. We'll hop to the main screen. Maybe talk a little more video games here. Go to the main screen. Who's here for my 320s? 320, it's time for you to learn, time to practice. Who's here? $50 first place, $20 second place, $10 third place. Who's here? Chapters 7 through 14. Yep, and go check out the review page. Good to see you here, Yakui. Good to see you here. Review for 201 currently in the chat. Angeli, good to see you here. Angeli, I think I know another person we're meeting about their applet. One person right now. We got 2 people with 3 prizes. Oh, that'll be interesting, right? Oh, we got 4 or 5 people joining in. Chandler, good to see you here. Got a bunch of people joining in. A little bit of music. How's everyone's nights going? I said we get started. We're getting started a tiny bit late. Charlie's here. Jacob's here. Oh, we'll get started here in 2 minutes. We've got about 22 questions to go through. Lots of concepts. How many people? Yeah, you're welcome. I appreciate it, Matthew. Man, we're all here for each other. Terry is a huge leader. I got to see quote 112. I know, right? Terry is doing a great job. He's helping us stay organized and leading the way and helping with our graders. Natalie, good to see you here. Quote 112, classic. If you were not here moments ago for quote 112, you'll be like, what? Wait, what? Mubot, where you at with the quotes, man? Mubot, you awake? If you were not here, you missed out on all the fun. Now, what would be really interesting is if the 201er hangs out and wins the game. Oh, 320 knows about the jokes. We're going to get started here in 1 minute. So join in. If you're 201, you can still play. You're more than welcome to play. I used to think correlation implied causation. Then I took a stats class. Now I know it doesn't. Sounds like the class helped. Well, maybe. I love it. Absolutely love it. Once again, a lot of these topics come down to practice. Practice, practice, practice. We're here to practice. We're here to review. We'll be doing some review this week. Let's get that OG joke going right there. Who's your main in Smash? Or wait, what is the best video game console? Let's ask that real quick here. Best console. We got to ask this. Let's ask this to start. PC, PlayStation, Xbox, or is it Nintendo? What is the best console? I'll put that in the chat here as we get started. So it is about time, 20 seconds till we get started. Join in right now. Get ready right here. I already played that one. Xbox is winning out with 1 vote right now. Oh, I got to check my fantasy team. I got to check. How's Brian's fantasy team doing? Oh, no. Oh, my team crumbled in that league. Seriously? How's my team doing in our other league? I always look at my money league before my student league because I care about the league where I can win money. Not in this. It looks like I'm going to lose both. Awesome week for fantasy. You never know. Never know. Never know. So we got it. We're starting here in 10 seconds. Join in. We lost some people. What happened to the people we lost? Starting in 10 seconds. 10 seconds till we start. Join in. We're about to get started. Here we go in 5. I need some I'm raised in the chat. Put some I'm raised in the chat if you're ready to review. We got some questions coming up, really great questions to review. Put some I'm raised in the chat as we go here in 5, 4, 3. I need some I'm ready's in the chat. 2. Like the stream if you want. Go ahead and like the stream. Outweigh those dislikes. 1. We need an I'm ready. Someone needs to say I'm ready because we need to be I'm ready right here. Here we go. Let's get this going. Angeli's ready and Brian's ready. Here we go. Starting now. First question of the night deals with a QQ plot. So take a look at this QQ plot right here and state your decision about the QQ plot. What do you think about this QQ plot? What does it tell you? Good to see you here, Sydney, Natalia, and Wilton. Good to see you. Who's going to win the $50? The second $20 second dollar. Second place, $20, and third place, $10. Who's going to win? Good luck. Thank you, Matt. Matthew, 100 points helping out, being positive to 320 right there. What does that QQ plot tell you? Good, I'm not blocking the right answer. Well, I mean, not completely. QQ plots are used to do what? What are QQ plots used to do? What are QQ plots used to do? So it allows us to analyze what? QQ plots are very important. What does a QQ plot allow us to do? Who knows what a QQ plot allows us to do? Also known as a normal quantile plot or a normal probability plot, it allows us to see if a distribution is what? A QQ plot will allow us to see if a distribution looks what? Like if I have a vector 1 through 100 or 1 through 1,000, and I call it x, and I go here to QQ of x. Whoo! It's basically a test for normality. How does this distribution actually look? 100 points in the chat. The series of numbers 1 through 1,000 actually looks what? The series of numbers 1 through 1,000 would actually look what? Who knows for 100 points in the chat? It would actually look what? The series of numbers 1 through 1,000 actually looks this way. The series of numbers 1 through 1,000 actually looks what? It's just one. Here's the numbers 1 through 1,000. The series of numbers 1 through 1,000 actually looks what? It actually looks what? One word for it. Good review of 201. The series of numbers 1 through 1,000 would actually look whatly? Oh, I'm on Top Chat this whole time? You gotta be kidding me. The series of numbers 1 through 1,000 looks what? Once I show the histogram, the answer will be given away. I don't want to show you the answer yet. I want you to tell me. How does it look? It goes 1, 2, 3, 4, 5, 6. Here, wait. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It just goes like this. How's it look? The distribution would actually look what? I'll show you it. Well, what word describes this? Flat, you are correct. And it looks like it has one form. Like, it looks one form, so it looks this. What word am I looking for when I say it looks one form? It definitely looks not normal. I'll agree with that. It looks one form, so it looks this form. It looks one form. It looks uniform. Wilton right there, and everyone the 100 points, and Max also. And so does it follow the normal? No. But what about if we did a histogram of random normal numbers? Now this is actually random normal numbers, and then this QQ plot will do what? Here, I'll store them. This QQ plot, if this is stored as like a Y variable, this data right here, which is normal, this QQ plot, explain to me, since it's normal, the QQ plot will do what? Great job, Sydney, also. Sydney at 100 points. Great job. So this QQ plot will do what when I make it? Unlike this last one, which did this new QQ plot for this distribution will do what? When the data is normal, the QQ plot will show that it follows the what? So now that we have data that's more normal, which is unimodal symmetric, the QQ plot will show us what? Which this is why we need to look at QQ plots. It'll show something that follows more closely the what? It follows more closely to the, do you see it? The red line is the normal. No, it has started. We've already done the first question. So hop in right here, Daniel. Oh, sorry, Daniel. We got the first question going right here. The Kahoot has started. The distribution follows more closely to the red line. It's kind of like an XY line, but it's like a line that if it's normal, it follows. You see how this one does not follow the normal? This is the normal line right here, and these are kind of your leeways. So if you look at the first question on the Kahoot right here, does it mostly follow the red line? Does it mostly follow the red line? Now, these are your kind of like, yeah, it's okay. Does it mostly follow the red line? Is with them in the mostly the boundaries of okay? Yes or no? Does it mostly follow the red line? Yes or no? Does it mostly follow the red line? Does that mostly, and here I'll go away so you can see the pin behind me right there. Does it mostly follow the red line? Does it mostly follow the red line? Yes. And from that, we will conclude that it is normal. So since it mostly follows this red line, we have now reached the conclusion that it's normal. But to contrast that, does this one here mostly follow the red line? Does this distribution right here mostly follow the red line? The answer is no. And from this, it's pretty obvious that this distribution of data, which is right here, it does not follow a normal pattern. Okay, we'll hang on just a second here. But why do we use, who can explain in the chat, why do we use a QQ plot? Why do we use a QQ plot? QQ plots are used to analyze whether or not data is what? QQ plots are going to be used to analyze whether data is this or this. And this one is not it, and this one is it? You can see it right there as I show it. So once again, this data right here is not this, not it. This data is it. The whole point of a QQ plot is to tell us whether data is normal or not normal right there. Normal or not normal. The more closely it follows the red line, more normal it is. The more it deviates from the red line, the less normal it is. This is pretty normal. Follows it decently. We'll have ones more obvious on the test if it breaks normality. Here we go with the next question. Let's hop in here. Remember, the code is in the corner if you want to jump in at any time. Let's go to the next question, and it's anyone's game. There's 20 questions, and I'll tell you this much. Be here for the knowledge and be here to try to win, because it says I'll be able to join soon. Yes, here we go. Next question. Compute the expected value for Verizon rarely. So how do we get expected values? Expected values are row total times column total over grand total. Row total times column total over grand total. So we need to go to Verizon. Here's Verizon. And we need to go to rarely. Hope people had a calculator around. Get your calculator if you don't have it. So there's Verizon and rarely. I think I can use my new Epic pen to draw on the screen. Let's see if it works. We'll solve it here in a second and try to draw on the screen and draw the mathematics. So we have Verizon rarely. Oh, no, we caught a lot of people off guard with that one. So what is the formula? Remember, the formula is, I just put the Epic pen on this computer. Row total, oh, it's showing up good, times column total over grand total equals the expected. So can anyone tell me what the formula is? Take a moment right here and solve it for yourself. Who can solve this formula? What is the row total? What is the column total? What is the grand total? Who knows the row total, column total? Charlie's got it right there. Great job, Charlie. Row total is this right here. Here's the column total. We multiply those together, and then we divide by the grand total. Notice that we're going right here. Can I change colors? I don't know if I can change color. Oh, I can change color down here. Oh, I don't know how to use this yet. This is the total there. Is this making sense right here that we're just going across? We're saying Verizon rarely. So we take the row total for Verizon. We take the column total for rarely. And we multiply those together. And then we divide that by the expected. And that should equal 234. This is when we are doing two what variables. Help me out with this. What kind of relationship are we looking at between variables right here? So we're looking at the what between like two sort of what variables right here. We have, do you have Verizon? Do you have your dropped calls rarely? So what kind of variables are we dealing with right here? This is, what is your cell phone provider? Categorical. This is relationships between categorical variables. And one last quick question, how would we visualize this? This is a contingency table. Contingency tables always go with what? A contingency table is always paired with a what? Anytime you see a contingency table, if we have here like someone's class level and are they in Greek life, there's a contingency table and it always is paired with a what. If you would see a contingency table, you'll probably see this graphical representation with it. And the graphical representation you would see is going to be a mosaic plot. So the contingency table gives you the counts of the observations within. And you might have other sort of things. Great job right there, Sydney, everyone. Yep. Mosaic plot is the graphical representation. So you can see right here in our sample, we had very little freshmen, a lot of juniors and sophomores right there, little seniors. Here's the marginal display for people who are in Greek life. Here's the marginal display for class level, and that's just displaying one variable at a time, which that information is contained over here in the contingency table. So good review, categorical variables right there. Let's take a look at who's in the lead. Epic Bear versus Epic Pen. Let's find out who's going to win on the next question. True or false, side-by-side box plots compare a categorical Y and a quantitative X. True or false? Side-by-side box plots compare a categorical Y and a quantitative X. So put a categorical Y in, like class level. Then put a quantitative X in, like, let's say, I don't know, GPA. This one's a bit tricky. When we think about side-by-side box plots, and let's take a look right here. I think Jump makes it very clear. Let's test it out. When we do this right here, we want to put something in like height and class level. And what was the trick on this one? What was the trick right here? If I go right here and go to quantiles, you see it. Who notices it now? Who notices it? That was tricky. That's a tough one. What is the trick right there? I don't know if that's a trick question on the test, but that's a trick question. One of these variables is categorical, and one of these is quantitative. Technically, you could, usually we think of side-by-side box plots as like the y variable of interest being analyzed is quantitative. The difference is, and this is very important for later, is if you switch it, when you do it with a switched analysis right here, are these side-by-side box plots. And this is something we'll get to later. So if you notice right here, the x variable, it's right on the screen. I do like this new Epic Pen thing. It seems to be working pretty well. The x variable here is quantitative. Oh, the x variable here, I'm going to change colors, is categorical, and this is quantitative. And now here we have categorical and quantitative. Bit of a trick question because I just catches people off guard. But when we think about side-by-side box plots, we usually do the analysis, especially if we're doing it to analyze the difference between means or medians. You will see right here that we have right here a categorical X, breaking things into categories, and a quantitative Y. So looking at the analysis right here side by side, and I'm using jump so we can view it side by side. Does anyone know how in R we could do any sort of these analyses right here? How could we inside of R do these analyses? How could I get the view of how gender is maybe impacting height or vice versa? How could we do this analysis inside of R? So let's see how to do this analysis inside of R, which is kind of a good thing for us to see, especially with the take home and everything. If we wanted to do these analyses inside of R with survey 10, best survey ever. So we go here to survey 10, and what function would we use to look at how these two variables are impacting each other? What would we do to see how something like, how would we do this? What function would we look at to look at the impact of one variable on another using a code from our class? What function would we look at here? Who knows? What function is going to allow us to analyze how one variable impacts another? It's very important that we know these outputs right here. Very important we know these outputs. What function allows us to look at the impact of one variable on another variable? Not check regression will check conditions for a regression after a regression is made. So check regression, which we'll have some questions on that coming up, allows us to look at, great job Natalia right there, associate. So associate is going to allow us to look at the association between like something like height and weight and data equals survey 10. Now, because I've chosen two quantitative variables, I will get a scatter plot. If I switch this to a categorical X, I'll get my side-by-side box plots. And I believe Petrie does have it coded that if I switch it here, are we going to get logistic? We do get logistic. So notice how right here we have a categorical Y and a quantitative X. So the associate function allows us to look at the association between two different variables. The other combination I have not done yet, I think handedness. Oops, there we go. So handedness is giving the mosaic plot right here and allowing us to analyze the mosaic or the contingency table of handedness. But please notice the difference right here. I just did all combinations. This is a logistic regression right here. Here is side-by-side box plots, and here is quantitative. So let's repeat. Two quantitative variables, scatter plot. Categorical X, quantitative Y, side-by-side box plots. Logistic regression, which we will get to, categorical Y, quantitative X. We will get to that later on. And here's two categorical variables. Gender and handedness are both categorical. And that's pretty much all the permutations of the things we have. A little bit of a trick question right there and showing how to solve it and what we have. Let's continue on. It's anybody's game right here. Let's see who's going to win with the next question. I told you it's anybody's game. These questions might be tricky and it's great practice for you. Here we go. You got this. Next question. True or false? Scatter plots compare a quantitative Y and quantitative X. You got this. We just reviewed this. Not a trick question. If you think you know the answer, I'm not trying to trick you here. Wilton, you got this, man. Don't worry. Everyone got spun around by that question. People probably got that question. We're just guessing. They're like, I don't know, false or whatever. They're like, oh, I got it. I guessed, and I didn't know it. When less than half the people get it, it makes you worry. I don't think I have any other big trick questions on here. What is the condition from 201? QQ straight enough, no outliers. So we have scatter plots compare quantitative, quantitative. And I will try to drop hints. So we try to review and make sure we know 2 quantitative variables will end up in a scatter plot. And just once again, you can see it right here inside of R that we have height and weight, 2 quantitative variables, and we have scatter plots. So a scatter plot is going to be 2 quantitative variables. Leaderboard is going to be bouncing around, I bet. Leaderboard is going to be bouncing around. Let's find out the next question. Who's going to win? More true or false? Histograms display categorical variables. Got all those equations on the screen. Do histograms display categorical variables? Don't want to tell you the answer. It's hard to not say the answer. I'm trying to drop hints. Histograms are univariate. They display one variable. And histograms display things like height, weight, GPA. Even working in senior level classes, sometimes I have to be like, oh, you want to use a histogram. Someone will say I want to use a bar chart. I say bar charts are for categorical. Histograms are for quantitative. Histograms are for quantitative. Histograms are for quantitative. So if we go down here and we go to hist, survey 10, I wonder what it'll do. I've never tried this. See what it says? I've never tried that, but it's making it clear that the histogram right here is for quantitative data. So histograms are for quantitative data. Histograms have a number line on them, but if you wanted to display something like a categorical variable, how could you display a categorical variable? So to display a categorical variable, you could make a what? Oh, that's all right, Max. That's all right, man. Don't worry. You got this. Just write down everyone that, if you want to practice, just write them down and you got this. I'm going to put this up on the screen. Please take a screenshot of this if you want. This is all the graphics. This is everything right here on the relationships of how they work. So if you want, take a screenshot of this. I use this in 201. It's a good review. Don't worry if you're getting things wrong. It's practice. These are the things we learn first, or the things we practice first. So sometimes we forget them, but you can see the relationship between all the variables. I would take a screenshot of this. It's how all the variable combinations work. You can see things like bar charts and pie charts at the top. Remember, bars and pies go together. You can ask someone, what's your favorite pie? What's your favorite bar? Make a bar chart of your favorite pie chart of your favorite bars. And then quantitative distributions are like histograms, box plots, stem and leaves, and dot plots. And there's your scatter plots and time plots over there. And then there's your side-by-side box plots with the y variable being quantitative and the x variable being categorical. And then logistic regression right here. So this right here, I should have showed this at the start. It said, use this picture. But good review of the stuff right here. Take a screenshot of it and definitely know that. I'm not even joking. That's helpful for any class in analyzing data. That is a big help right there. So don't worry if you got it wrong. We're here to practice, and you're going to remember these things a lot better. You just have to repeat them. And a lot of people think that bar charts are like histograms. I get them usually confused because they've got bars. They both have bars, so they look very similar. Next question. Ooh, told you it's going to be a crazy game. We'll start settling down here as we get to the newer material of the recency effect. Here comes the next question. Here we go. What is the best way to investigate normality? What is the absolute best way to investigate normality? I hope everyone knows this. What is the number one way we investigate normality? I want to hit click skip. What is the number one way we investigate normality? We were talking about this earlier. So if you were here at the start, you should be like, I know it. We were talking about this a lot. It's the number one way to investigate normality. Number one way. And then I'll repeat why we do this, why we investigate normality, which is on your quiz. The number one way to investigate normality, aside from a p-value test, would be those. I think it's worth it. I'm doing it. I'm giving 1,000 points for you. I told 201 I'd do it if everyone got the question right. There's your 1,000 points. I'm so happy and I'm so shocked. I was worried we would get closer to 50, 60%. No, it's not. I promise I don't try to throw that many trick questions out there, Wilton. But there's the 1,000 points right there. Big points. Show up for the fun and everything. Let's go right there. Everyone getting it correct. Love it. Make it happen. Make it bring some points. But that's what I like to see. QQ plots, check for normality. That's the way we should do it. Don't look at the histograms. 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 Let's go ahead and check it out. But let me ask you this. Why do we investigate normality? Because oftentimes, if we're comparing groups, we might be asking ourselves, should we compare what or what's between these groups? If we're investigating normality, which we can do down here, and I'd say there's slight issues, I'm going to say this is mostly normal. This decision's moot on the p-values. I'm going to say this is mostly normal. And then why would I want, and this is the output for it, why am I deciding? I'm going to say it's mostly normal. There is a bit of an issue down here. I know I'm looking where I shouldn't look, but that's what it goes with. There's a bit of an issue there on the bottom, but I'm going to say it's mostly normal. I'm going to say it's just on the edge of what I'll take. This one's fine. This one's fine. Everything's fine. That's fine. That's fine. That's fine. That's within the bounds of sure. Why am I investigating normality right here? And the answer is very small to see on the bottom, but why am I investigating normality? Why do I care about looking at this? Which goes to your quiz questions. Why do I care to look at normality? Because I'm making a choice right now to compare a measure of central tendency between what and what. And when I say, it looks mostly normal, these mostly follow, it's a bit of an issue, but I'm going to say it's okay. I know, it looks a little bit bad down there, but I'm going to say it's okay. To determine if we should use means or medians. If this had looked really bad, I would use the medians. I almost misspoke. If it looked really bad, I'd use the median. If it looks more like the normal, which this looks excellent. That looks great. Don't look at the histogram. This looks great. I mean, it's not a sneak peek. But this one right here looks badish. If some statistician said use the median, I wouldn't fight them. But not that I fight anybody, but I'd use the mean. I'm okay with that right there. That one's a little iffy, but I'd use the mean. Iffy. It's iffy. Not normal, medians, normal equals means. Exactly. And does it follow the red line on the QQ plot? So look at that. Or you can I don't like arguable ones. On written tests, I'm okay with it. But like if a written test says like justify your decision, I'm cool with that. But on like an online test where it says like which one would you use, I prefer it to be more cut and dry. If you could justify your decision by writing it out, someone could say like it's on the edge of what I would expect. I don't expect anyone to say that looks perfect or looks great or looks horrible. It's more of an edge case one. You get some ones that are pretty obvious though. Like, let me choose a variable in survey 10 that's gonna be ridiculous. Like, I think we have some big ones, right? Like, weekly hours video games, 2 seconds. Attach survey 10, gender, weekly hours video games. Yeah, okay. If you, if you tell me to use the means here, I say no. And but I'll make a case for it and I say no. You're like, but it follows the red line here, and I say, but no. This is like one of the ones that would be very obvious on the test. I mean, and then you say, well, can I look at the histograms? Well, yeah, you can look at the histograms. Don't look at the histograms generally. You really want to look down here at this. The histograms are going to be controlled by binwidths, so you want to look at the QQ plots for normality, and these are ridiculous. They're horrible because the variable is so skewed that the medians would be more appropriate. We're going to plot, yep. Cool. Let's check out who's winning right here. Leaderboard's all tied up. Who's going to win? I don't know. Next question. Here we go. Quiz question. If two relationship between the variables is monotonic and linear, which option should you pick? If the relationship between two quantitative variables is monotonic and linear, which option should you pick? That's all you know is that it's monotonic and linear. Ooh, this is on your quiz. Or it's shown graphically. Relationship between two variables is monotonic and linear. Let me ask you this. Are all lines monotonic? What does monotonic mean? Are all lines can be over there in yellow. Are all lines monotonic? Are all lines monotonic? Oh no, that's all right, Daniel. Are all lines monotonic? What does monotonic mean? And are all lines monotonic? Like by definition. Let's draw this out here. Let's draw it out. Are all lines monotonic? A line or data that goes in the form of a line will go like this. And oh, no worries. Wait, but what does monotonic mean? What does monotonic mean? Monotonic means it does what? Define for me monotonic. It's your favorite band. One direction. It goes in one direction. So tell me, does this go in one direction? Does that go in one direction? So anything that goes in only one direction mostly is monotonic. And what do we mean mostly? Like, you might be like, well, that goes down at the end. Well, this is mostly monotonic. Like, for the most part, it goes in one direction. It's going up at all times. It could be monotonic down. So something that would go just downward, like would be monotonic down. Just depends if it goes up or down. Just goes in one direction. So this is monotonic up. all lines, by virtue of it being a line, have to go in one direction. So lines are monotonic. Now, what is the choice when we have two quantitative variables? We would choose between what types of correlation to talk about their relationship. When we have, and these are the notes you should have. People ask me a lot, like, what notes should I have? Yep, this is great question, Max. This is monotonic but not linear. So this goes in one direction. It's monotonic up, but it's not linear. So monotonic, yes. It's monotonic up, but it's not linear. It's not well described by a line. So V would not exactly, things can be not monotonic. So this over here would be something that is not, or a parabola. Parabolas or V's are not monotonic. So why are we trying to think about the relationship that these variables have between two quantitative variables? Because the choice here is between what and what to describe them. We're going to use what or what relationship right here. This is recorded, yep. So we're going to choose between what and what. We're going to choose between what and what to describe the relationships right here. The choice on how to talk about this via correlation will be we are either going to use this or use this to describe the relationship. What will be the choice? Pearson or Spearman? Natalie, great job right there. Pearson or Spearman? And Spearman has in it the qualities that it needs to be monotonic. This is going to be linear. No outliers. And no heteroscedasticity. Das. Sure, we'll just add some more letters. No heteroscedasticity. So Pearson is basically just your classic old linear regression. But Spearman can handle a lot of issues. But which one should we use for this? Which one is this going to be a relationship by? Let me put the answers here. So if you think about what the answers are, this is going to be Pearson. This is going to be Spearman. And then the one there in the top corner is actually going to be what? So the one there in the top corner would be what sort of relationship? So this one is linear. This one is Spearman because it's monotonic. Can't use either and neither. Doesn't apply because it's not monotonic. It's not linear. It doesn't follow any of the relationships. But do remember, lines are all monotonic. You might say, well, didn't the last question say it's linear and monotonic? It was there. It'll trick you a little bit. But Spearman and Pearson, the decision to look at these are based on the relationship the points have. So you need to ask yourself, are there issues with outliers? Like, let me ask you this. If I had data that looked like this to review, I will draw a plot. And then, what correlation would you use right here? What correlation are you going to use for this? And why? What correlation should you use for this and why? So you ask yourself, is it linear? Yep. You got it. Spearman. Why Spearman? So go back once again to your notes. And why are we using Spearman right here? Why are we using Spearman? Make it a little I don't know, tiny thing over here. Why are we using Spearman? Because of the heteroscedasticity. We don't, for Pearson, you must have just basically good, even spread of points. And so the Spearman is going to be decided upon right here because of the heteroscedasticity. You do not want heteroscedasticity. You do not want outliers if you're going to use Pearson. So this would be a Spearman relationship. We describe it better with Spearman than Pearson. Good stuff right there. Let's hop back in. Let's see who's winning. I tell you, it's anyone's game. It's anyone's game. Let's find out who's going to win here. What is the lowest possible p-value? Ooh, easy question. I hope this is on the test. I hope it is. Let's see if we can get another 100%. Does equal spread refer to... would be equal spread is referring to homoscedasticity. Homo being same and scedasticity being spread. So equal spread. Join in, Kayla, right there. Yeah, Kayla, join in. 100 points, Kayla wanted to join in. Join in and have some fun, Kayla. See, look, we got some equal spread questions in the chat. Some homoscedasticity versus heteroscedasticity. So it's good review of tool 1. Hop on in. Game pin right there. 7911875. Lowest possible p-value. Oh, wait. P-values are what? Can anyone explain what a p-value is? Yeah, you're thinking of R. Yep. R goes to -1, which is perfect negative correlation. Kayla, thank you so much. Glad to have you here, Kayla. What are p-values? P-values are the what of our results or results from our stream happening by random chance variation given that the null hypothesis is true. Oh, no worries. A lot of people thought it was correlation. But p-values are the what of our result? The probability of something or more extreme happening by random chance variation given that the null is true. So the lowest possible p-value is 0 because the probability... Max, great job. And good review from last class, right? We were reviewing this. The probability that data happened by random chance exactly, given the results by random chance. I gotta watch out. I'm gonna get copyright claimed if I do that too many times or too long. Monster Cats hit me with one. The probability of our results occurring by random chance. Yeah. So it's basically like, could randomness make our results? And if randomness can't, then we think our results are unlikely by random chance because there's a probability of our results being by random chance. Good review. Kayla, 100 points. Love it. You got it. Good practice for 201. Oh, and you said, Kayla, aren't you taking 320? I think Kayla's taking 320. If you're going to give shout outs to Kayla, she's taking 320, I think, coming up. So shout outs right there. Focused Lobster is focused in on the win right there. So Kayla gives some good review right here. Let's find out. Next question right here in the spring. That's awesome. I'm excited for right there. Everyone's still cracking up about quote 112, Kayla. Everyone is still cracking up. True or false? Correlation implies causation. I bet, Kayla, you got this. Kayla, once you answer, I want you to just spam that answer in the chat with caps lock right there. Correlation implies causation. Correlation implies causation. And I will not lie. I was ready to shout an answer. And I was like, wait a minute, it's the reverse. I seriously, if I was putting... Yeah, nice job right there. That is false. Correlation does not imply causation. My brain was like, true. Wait a minute. That is so false. Correlation does not imply causation. We talked about some examples earlier. I think I've got it up here drawn still. We did it way earlier. I don't know if I still have it. Here we go. So another example. This is from 201. So we do cover this in 320 also. If we say how TVs... are correlated with people living longer. Like the more TVs you own, the longer you live. The longer you live, the more TVs you own. But there's a variable hiding here in the background. What do we call this variable hiding in the background that is the Z variable that's really impacting the X and the Y? What do you call it? It's hiding. It's, yeah, you got it. It's lurking around right there. That lurking variable, Kayla just crushing it right there. Good practice. Once again, we cover a lot of 320 things in 201 and vice versa. It could be confounding, like it's contained within the other variables. I like that right there, Natalie, and Natalie's now a mod too. It's confounding. It's kind of within the other variables, so it's confounded with. There's a good terminology. Confounded things are lurking or like the variations shared between. Love it, Max. Let's use the lead right here. Leaderboard's getting shook up right here. Let's check it out. Next question coming right up. The model uses a starting point to compute the total sums of squared error. Someone's going to get this super quick. This is the no knowledge model. The no knowledge model, the model that has no knowledge. The starting off point using the mean of y, a good note to have about this model right here is that it's the mean of y. So this is your no knowledge model if you just plot the mean of y and then compute the sums of squared. We actually talked about this earlier today for 201. I was like, I'll go into more detail in later classes. So this is the starting model. It's not your regression model. It's actually going to compute the total error that exists, and it's called the naive model. So the naive model is the mean of y. How does this look visually? If we just go over here and compute a naive model, we could do something like plot height, weight, and I've got these stored as vectors right now, I think. And how does the naive model look? Go to AB line and go to horizontal equals mean of survey 10, $ height, and there it is right there. What would you do? How does this model work? This model right here is going to predict what? Just think about how this model works. Just tell me, this model would do what for everybody? This model would predict that everybody is what? It's going to predict everybody is 67.74 inches tall. That's what we start out with. It's the average of y. And it's just the starting out point from which the sums of squared error of the model is computed. So you could actually literally go through here. And where do we see the sums of squared error? Well, here's the mean of y. So let's call it mean y. Now let's take the observations. So the sum of the squared error from the naive is going to be, we're going to take and we're going to sum up the error. And let's go here to the mean of y minus the observations. What is Brian calculating here by doing a model minus the actual value? Who knows what I'm calculating by doing an observation minus the actual value? Actually, let's save it over here. What am I doing by doing a observation minus, like this is a model. So what am I calculating right here? I'll give you a hint. It's actually a what from this? What am I calculating from this? A residual. So I'm calculating how far that model misses because it's just a model. It's not a, does that make sense? That's just a model right there. So we're calculating the residual, the actual minus the predicted. Now, if you want to get more exact, I put a typo right there. You might say, well, Brian, you need to do the actual minus the predicted because the model is making predictions. And now we're going to take the residual and we're going to square it. And this is the sum of the squared error from there. Why do we, and this is a good 201 question, why do we do the sum of the squared error? Why do we square the error? Why not just do the sum of the error? And I hope it turns out that is basically a number. What is the sum of the error? What is the sum of the error? There was some decimal change that is very, very tiny. Residuals can be positive and negative because it's above and below line. So what is this? It didn't carry enough decimals on some of the calculations. What is this rounded to like 10 decimals? If I round this to 10 decimals, what is the sum of all the error? Like, so Natalie's doing it. Yeah, that's a really small number right here. It's just some decimals are not properly getting carried because it's doing long decimal place calculations. But this right here, the sum of the residuals is 0 if you sum them all up because they're positive, negative. So if you're calculating a sums of squared error, you're squaring the error, and that's what we talked about a little bit in 201. So rather than just doing the sum of the error, we do the sum of the squared error. So now we're getting a sums of squared error. But what if I do this? Last question on this. What if I do this? I take the mean of this. Let me take the squared error. And so I take my squared error and I take the mean of the error, but then I don't want it in squared units. Hints for your take home. Maybe I'll drop a big hint. And now what have I found? So this is the root mean squared error, also known as the typical miss the model makes. That is the root mean squared error, residual standard error, root mean squared error, goes by a lot of names. RSE, residual standard error, root mean square error, typical miss of the model. When we predict somebody's height using the mean, we are typically off by about 4.4 inches. Big hint for the take home for anyone wondering, and I'll repeat that since any tips would be given out generally to everybody. A lot of people have asked. But the RSE, the RMSE, and the typical miss are all the same thing. Just putting that out there. Yeah. Let's hop back to the main screen. Okay, let's see who's in the lead right here. Good stuff. Epic Bear leading the way epically. Let's find out with the next question who's going to win right here. Which of the following is not a condition for regression? Kayla and everyone, you got this. What is not a condition for regression? Hopefully that helps out, Daniel. I didn't say what the answer is, but I kind of alluded to some stuff. What is not a condition for regression? We have 3 conditions when we check our regression. When we do check regression, we'll look at some check regression output here. Great job. So the condition that we wouldn't be using here is random. We have QQ, straight enough, no outliers. The QQ isn't on here, but you can see the straight enough with the linear. Equal spread is going to be plot doesn't thicken, and normality of residuals goes to the pattern. That's the 201 way we talk about it with QQ, straight enough, no outliers, plot doesn't thicken. But we're going to look more at these conditions here in a moment and look at some check regression. Focus Lobster, great job right there. Let's see who's going to win. True or false? Residuals should be independent of each other. You might say, well, wait a minute. So yeah, just think about this. Residuals should not have any pattern. It is true. Well, there you go. I've been teaching for like 5 hours. I didn't lie right there. It is true. Residuals should be what? They should be independent. They should not follow any patterns. Residuals should not. They should just look completely random, which means they'll be under a normal. We don't really call it a random condition. We say that they should follow the normal pattern, but like just randomly under the normal. We'll look at this coming up here with some questions. Let's take a look. Residuals should just be independent of each other, have no pattern. Probably the best thing you should write down is residuals should have no pattern. And we'll take a look at some residual plots here in a moment. Next question. Here we go. Quiz question time. What is the uncertainty of the slope? Look at the output and tell me the uncertainty of the slope. The uncertainty of the slope, whenever you hear uncertainty, what should you think? Whenever you hear uncertainty, now, don't always think typical miss the model makes. When you hear uncertainty, you should think 2 words. And those 2 words are on here in 3 places. I like a K right there. Good guess. Uncertainty is not really unknown. Uncertainty is more like you're like if I tell you, and I'll answer this way. If I tell you dinner will be at 7 p.m. plus or minus 20 minutes, what's the uncertainty right there? If I tell you dinner will be at 7 p.m. plus or minus 20 minutes, what's the uncertainty right there? Dinner will be at 7 p.m. plus or minus 20 minutes. What's the uncertainty? Dinner will be at 7 p.m. plus or minus 20 minutes. The uncertainty would be what? The uncertainty would be dinner will be at 7 p.m. plus or minus 20 minutes. Mun, great job. Mun jumping into the rescue, 20 points. Mun. So it'd be the 20 minutes. So when you look at this right here, how many different uncertainties are there on this screen? Well, we're trying to estimate multiple things. So we have an estimate of the intercept, and you say, I think the intercept's about negative 0.26, but I could be off by about 0.006. I think the diameter, which is the x variable, could be about 1.09, but I could be off by about 0.015. I think the typical miss the model makes, residual standard error, the uncertainty in the residuals is about 0.05. So this is the typical miss the model makes, the uncertainty in the residuals, residual standard error. But the uncertainty in the slope is we have an estimate of the slope, and then we have the standard error. Take a moment right here, and I will throw 500 points for anyone who makes a confidence interval, 95% confidence interval for diameter right here. And Kayla, this is a good question that would actually go to a lot of the theory we're about to do. So take a moment right here. Who can make a 95% confidence interval for diameter? Who can make a 95% confidence interval for diameter? And what would you do to do this? Ditto. Ola, good to see you, Ditto. Sydney, good to see you here too. What would you do to make a 95% confidence interval for diameter? And then do it. You can do it pretty quickly. How would you do it? I'll let you round this right here. I'm coming up with it in my head. I've got the numbers for what I think the slope is contained in my head. Max, you might not have... Oh, Max, you are right. Max, 500 points. Brian didn't carry his decimals properly. Max, while you're... Max, I want you to explain to everyone how you did that. And I'm going to show you. Max is correct. Brian didn't carry his decimals. I did one too many. Was that meat, weight, and diameter? Max, explain in the chat, because a bunch of people are probably saying, how in the world did you do that in your head? So, Max, give us an explanation. Help us out, Max. This is the EX3 abalone data set. And it's meat, weight, and diameter. So let's go here. LM, meat dot weight, tilde diameter. Data equals EX3 abalone. And summary. There it is right there. Great job right there. So what Max gave was 1 point, here, I'll put up Max's answer in the chat right here. 1.06 to 1.12. And then if we go to confident for the coefficients, not even joking, Max, I don't care. We're throwing another 500 points. Max's answers are how close to the right answers. I want to make this very clear. Why do we multiply? And so Mun asked a good question. I want you to look at Max's answers. I want to look at the right answers. And Max did that in his head. How close are Max's answers to the right answer? Max just is like, oh, it's probably about 1.06 to 1.12. Max did 2 times this. And why are we doing 2 times it? And this literally goes back to 201. Why are we going to 2 times it? Who can explain why we're doing 2 times it? This is 201 from earlier. I like to draw the connections. Why did Max do 2 times it? Why did Max go 2 times the standard error? Because 95% confidence. He's just going plus or minus 2. So hopefully, Kayla, this is showing you some crossover here between classes that Max just went and said, oh, let me take my uncertainty right here, and I'm going to multiply it by 2. So this is my margin of error. Margin of error equals 2 times the uncertainty. And then here's my estimate of the diameter. And I'm just going to go plus the margin of error. And then I'm going to go this minus the margin of error. Is that making more sense to people right here? Now we've created the 95% confidence roll. And if you carry more decimals, you might get more accurate. But Max rounded right there. But no, don't worry. It does it for you. The standard error 1. And so, Max, let me ask you this. If you had done 1 standard error, what kind of confidence interval would you have built then? If you had just done one standard error, what kind of confidence interval would you build then? If you did one standard error, you would have built a what? And so, Kayla, you might get this too. If you did one standard error or uncertainty amount, if you went out just one of them, you would actually be building, boom, you got it right there. You'd be building a 68. But you could build a 95 by going out 2 or a 99.7. You can build anything in between 2 if you want, but the more you go out, the bigger the interval gets. So you can notice from a 68% confident 95 or 99.7, the interval gets more confident. Now, one thing I want to point out right here is that this estimate for the slope does not contain what? And this is not the model you're seeing on the screen. The model you're actually seeing is this model here, which has a huge violation. Haha, yeah. But it does not contain 0. So we don't think the true slope of this line is 0, but there's some huge problems. Problem here, and problem with that, and probably problems with those over there. Yep. So hopefully it's showing you the collisions between the classes. There's a lot. And knowing the output is key. So great job, everybody. Good practice. Smart Rhino leading up. Let's find out who's going to win the next question. You got this. What is the typical miss the model makes? Oh, do it. Do it. You got this. What is the typical miss the model makes? Easiest question we can possibly put on here. We should know typical miss the model makes. The model typically misses by this amount when predicting the meat weight of a abalone, which is a tasty sea creature. The abalone, when we predict its meat weight using the diameter, the typical miss we would make, and I guess this is in pounds of meat weight, maybe. The typical miss we make is the residual standard error. Great job right there. Good review of the topic. Just knowing conceptually what it is. And visually speaking, if you think about it visually, it's about how far away these are. But Kayla, Kayla, do you want to drop any sort of concerns you have with this model in the chat? Yeah, Kayla, great job. Kayla, I don't care, 100 points, Kayla. Yep, because the residual standard error is the typical miss the model makes. It's about how far we're typically off. You see how we're like, this is very small units. So when we miss, the typical error of the residual is about 0.05. Like that's how, it's just telling you like, residuals are how much we miss by. So when we miss, the residuals have a sort of like uncertainty, like a plus or minus, like we're usually off by about 0.05. That's like the typical size of a residual. So if you were to look at the residuals, they're typically about this amount. And think about how we calculate it. It's the root mean squared error. So we take the error, we take the mean of the squared error and we take the root. So it's basically mean error. So the root mean square error, if you cancel these, you get what? So let me ask this again. If you cancel in root mean squared error, and this is the way to know it conceptually, root mean squared error. If you cancel the terms that cancel out, the RSE, the residual standard error, is basically known as what? If you cancel the words that cancel out, it's basically the what? If you cancel from root mean squared error, the canceled terms, because you have to do this to get a value or else you'll get 0. If you cancel the terms, you get what? Mean error. And think of it, that's like typical miss. Like this is my average error. So it's typical miss. On average, my error is this. So hopefully understanding the mathematics and the conceptual kind of bridges the gaps in what we're learning. Great job, Kayla. Excellent job. Another 100 points. Thank you for following along and everyone practicing right there. Wilton, good job. And so everyone, I love it. I like just feel learning. So here we are. There we go. Kelly, tell me what place you come in. I'm excited to hear. Next question. Let's find out. Question number 15 right here coming up. What percent of the variation y is explained by the variation in x? So tell me, use the values on the screen to tell me what percent of the variation y is explained by the variation in x. Who's got this? What should you be looking at immediately here when you hear percent of variation in y explained by variation in x? What should you be looking at? Percent of variation y explained by the variation in x. You should immediately, your eyes should go to what? Now there's 2 of them. So you might say, well, which one do I pick between? Well, luckily the answers on the screen wouldn't have you deciding between those. What should you be looking at right here? The percent of the variation in y explained by the variation in x is going to be your r squared. R squared. And r squared right here is a number between 0 and 1, but we always multiply this by 100. Now this is the penalized r squared and used in multiple regression. Although this is multiple r, I know that might be a little confusing. This is the r squared. This is the adjusted r squared, which accounts for multiple variables in the model and is always lower than r squared. Key concepts on this, I'm going to name 3 things for you right now. Adjusted r squared is always lower than r squared, except if r squared is 1. We don't put that on the test. Adjusted r squared can be negative. Adjusted r squared has no interpretation. It's basically r squared with a penalty. It's used when we have multiple models to see if our model has a bunch of bad variables in it, like variables that aren't pulling their own weight. R squared right here is the percent of variation y explained by the variation x. Any questions? What are people thinking? Are we good? We're getting to the end of the Kahoot. We'll probably finish in about 14 minutes tops. And thank you so much. Any questions right now? What are people thinking? Is it making sense? Is it a good review? Hopefully people are seeing this right now. We're going to continue on. Let's see. Let's see who's in the lead. Tight leaderboard. We got Epic Bear and Focus Lobster fighting each other. But you never know. It just takes one question wrong. Let's find out who's going to win. Quick question right here. What is the correct interpretation of the slope? Now be very careful. This is the 320 interpretation. We have right here a diameter. These are two abalones. Kind of gives it away. In this interpretation, and please review. We've covered this a lot, so please review the notes on this. Oh, that's so crazy, Kayla. Oh. Oh, a lot of people said for each 1 unit. Let me pause right here. This is where you might lose a lot of points on the test. This is how we do things like in 201. But in 320, which where we're more exact and we're very precise on our wording, two abalones that differ in their diameter. There'll be two. So no, there won't be. It's always we compare two. Let me ask you this right here, and let me make it more obvious with an example like this. If we use our height and weight example, let's go back to the height and weight model. So I'm going to look at a model that predicts somebody's height from their weight. So let me do this. I'm attaching survey data. So when I do this right here, and I predict somebody's height from their weight, I want us to think about this interpretation right here. If we use the words will, or as your weight increases, then what would this mean? The wrong interpretations would be things like, I hate saying this, sorry 201. For each 1 unit increase in weight, we expect somebody's height to increase by this. What we'd actually say is, two individuals who differ in their weight by 1 pound are expected to differ in their height by what? Two individuals who differ in their weight by 1 pound are expected to differ in their height by what? So two individuals who differ in their weight by 1 pound... Two individuals who differ in their weight by 1 pound are expected to differ in their height by what? Two individuals who differ in their weight by 1 pound are expected to differ in their weight. Two individuals that differ in their weight by 1 pound are expected to differ in their height. It doesn't exactly when you're right there. We can't say, yep. See, we're showing about two people who differ in their weight by 1 pound. We'd expect them to differ in their height by 0.07 inches, where the person who weighs more is expected to be taller. We're not saying they will be taller. We're not saying if you gain weight, you will get taller. Because if people said, well, if I just gain 100 pounds, well, then according to this model, if it's causation, I should gain 7 inches. No. But two individuals who differ in their weight by 100 pounds would be expected to differ in their height by 7.3 inches, where the person who weighs 100 pounds more is expected to be 7.3 inches taller. Please practice this. What do you get for your test? Please, I'm going to say this a bunch of times. What do you get for your test? What do you get for your test? What do you get for your test? What do you get? I don't have one in front of me right now. What do you get for your test? A cheat sheet. So what are you going to put on your test? What are you going to put on your test, on your cheat sheet? You get a front back note sheet. So who's going to be putting their interpretations on their note sheet? We'll cover this more when we get to class and we talk about especially on Wednesday. We'll be doing a review on Wednesday. Are you going to put your interpretations on your cheat sheet? Yes. Put your interpretations on your cheat sheet. Use from the keys, use from the assignments. Make sure you have interpretations. Every section gets a cheat sheet. That's universal across. Taylor, thank you for asking right there. 100 points, Taylor. Yes, I'll make sure everyone knows we've always had it universal that you get a cheat sheet and you get a front back cheat sheet. You can put your interpretations, make sure you have it down, because although you are memorizing it, you can be like, okay, let me make sure it makes sense. Make sure to write it out that it makes sense, that if I talk to you, it would make sense here when I say when we have two abalones, which are that fish thing, and they differ by diameter by 1 inch, then we would expect them to differ in the amount of meat weight we get from them by about 1.09 pounds, where the abalone that is a bigger diameter is expected to have more meat weight on it. I want you to again listen to this and just think, if I'm talking to you, does it make sense? If I have two abalones that differ in their size of diameter by 1 inch, then I would expect them to differ in their meat weight by 1.09 pounds of meat weight, where the abalone that is bigger is going to be expected to have more meat weight on it. Does that make sense? I'm kind of telling you that the bigger abalones we get more meat weight from. And how much? Well, when they differ by 1 diameter in their inch, then we expect to get about 1.09 more meat weight off of them in pounds. I believe it's pounds. We would give you units if it is a more serious problem. So I'm basically communicating to you that bigger abalones get more meat weight. Now, you don't want to just write that. You want to say, when we have two abalones that differ by their diameter by 1 inch, we would expect them to differ in their meat weight by about 1.09 pounds, where the bigger abalone is expected to get more meat weight off of it. Make sure it makes sense what you're saying. Make sure it makes sense. Next question. Here we go. Oh, I told you that leaderboard's going to get shook up. Next question. What is the margin of error for the diameter estimate? Oh, I love this. What is the margin of error? Oh, Max is probably answering away really quickly. The diameter estimate has a what margin of error right here? Do you know it? Do you know how to get the margin of error for an interval? This is amazing knowledge, Kayla, for coming up in 201 right here. The margin of error is always what the length of an interval. The margin of error is always this the length of an interval. The margin of error is always this the length of the interval. Repeat this, and who knows in chat, and then we'll explain why it's the answer. The margin of error is always what the length of the interval. Oh, we caught a lot of people. The margin of error is always what the length of the interval. So if we have an interval right here, who can give us the answer? The margin of error is always what the length of the interval. So here's the length of the interval. And the margin of error is always half the length of the interval. And if you remember from earlier, just to review, remember we were calculating the margin of error, and what did we do to get a 95% confidence interval? We did 2 times it. If you look at what's stored here in the margin of error, it was this right here. And remember, we're going plus or minus this. No, don't, Daniel. I'm throwing you 100 points, Daniel. Don't worry. These are the notes to write down. Like if you don't know it, then write, or if you just forget it, or if you get something wrong, write down that the margin of error is always half the length of the interval. If I tell you we'll have dinner sometime between 5 and 7, what's the margin of error of that interval? Really quick one right here. If I tell you dinner's between 5 to 7, what's the margin of error of that interval? I tell you, dinner will be between 5 and 7 tonight. The margin of error would be what of that interval? The margin of error would be what? Remember what we just practiced right here. So we always do a little practice. 1 hour, Brennan, great job right there. Better to miss it. Exactly. Miss it. We have a quote. I can't remember which quote it is. I got a lot of quotes. Like, get it wrong in class to get it right on the test. That's what we do. Caleb, more points for those positivity right there. Letting the other button load up right there. So we get it wrong in class to get it right on the test. Don't worry. Margin of error is half the length of the interval. Ooh, Epic Bear and Focus Lobster. Oh, but they got it wrong. Oh, wow. Let's find out who's going to win right here. Next question coming right up. True or false? The intercept can have no meaningful interpretation. True or false? The intercept sometimes has no meaningful interpretation. So think about like how multiple regression works. If everything's set to 0, like you're somebody who, with the Kroger example, somebody who lives inside a Kroger, has no family, and has no income. Or the height and weight example. You have 0 weight, and let's predict your height for someone who's at 0 weight. Sometimes that intercept is definitely what we would say illogical. And I love it because this is a 201 crossover too. The intercept can be illogical. You just have to say it to yourself, like when somebody, do we have a model up here? When somebody has a weight of 0, we predict their height to be 56 inches. It's an extrapolation of the model. Extrapolation is when you go outside the X bounds of the model. Yeah, not good right there. Not good, not good, not good, not good. No. Meaningless, illogical, no meaningful interpretation. Woo! Remember, $50 first prize, $20 second place, third place, $10. Next question. 2 more questions to go. How many tests are failed? Love it. Absolutely love it. How many tests are failed? Absolutely love this question. No, Epic Bear. Come back, Epic Bear. You got this, man. How many tests are failed right here? How many tests are failed? Epic Bear, come back, JK. When you look at these tests right here, looking at these tests, you want p-values to be above 0.05. Wow. We practiced that a lot. We made sure we had that down. So if I show you, let's go back and look at that meat weight model. What, and I won't let you see the output yet. It's probably going to pop the screen up, right? let's go look at the visual model. What condition do you definitely know? So the lower the p-values below 0.05 mean fail, Kayla. So when we do a check regression, which we're going to do here in a second, if the p-values are below 0.05, we fail the test. Just looking at this visually, I want you to tell me what you think we fail. Looking at this visually, I want you to tell me one of the things you think we fail about this model. And this is how we do it. Like some people might say, well, is it this? Like in 201, we look at it just visually, which we can assess the visual nature of this one and say there's a huge problem. And I'd say there's two problems that are really easy to see with this one. One being, I actually got them both right there. Linearity, it does not follow the line. And then there is some heteroscedasticity. There's the unequal spread. Kayla, Max, Charlie, great job right there. And you notice the unequal spread of it. So when we do the check regression, the null hypothesis for a check regression is that any condition right here is good. So null hypothesis being good condition, like linearity is good. The alternative hypothesis is bad condition or not good. Not good because that's a complement. So not good condition. So let's run this. And if you think about, because we've all learned, well, not everyone yet, we're going to learn more about rejecting the null and failing to reject the null, Kayla, coming up here soon. But when you look at this right here, is this p-value low? That means you reject the null. I reject that linearity is good. Yeah, oof, those residual plots. This right here shows us that there's a problem with the linearity because it doesn't follow the line. And once again, how do we make a residual plot? Who knows? You take this line and do what to it to make a residual plot? Here's the plot right here of the actual data. And then here's a residual plot of it. So how do you possibly turn that into a residual plot? So this residual plot here is our line. That's our original line. This line right here, the one I'm pointing at, is this original line right here, that red line. So we take the line, take that line, make it flat. And that's the residual plot because anything on the line has a residual of 0. And you notice that the linearity is not met at all. And you can see the heteroscedasticity in the cone shape. And last but not least, the normality plot for QQ. The QQ normality plot shows big problems here at the end. So all the conditions are failed. Now, what do we do after the conditions are failed? We see if the sample size is at least 25. It is, which means we can look at, yep, got killer right there. You're going to set it to 0. You're going to set the line equal to 0. We look to see if the sample size is greater than 25. You are right, Wilton, right there, and it is. So that means we can look at the plots, but the plots are super bad. This model right here is a major failing of all conditions. The other model, too, has problems. I think it was created from this. So yeah, that's, you'd have to look at the plots, and we did, and it's really bad. Don't use that model. That model is not a reasonable reflection of reality. Last question. Here we go. Let's check out the last question. Here we go. Last question of the night. After we fail a test, what is the next step? After we fail a test, what is the next test? The next thing we do after we fail a test, who is paying attention right there? This could be for all the beans right here, all the money. What is the next test? What is the next thing we do after we fail a test? What do we do? We see if the sample is 25 or larger. Wilton put in the chat earlier. Great job, Wilton, right there. We do check the diagnostic plots, but as long as we have a sample size of at least 25. Just to reiterate, it does show you this in the output right here. It says, advice, down here on the bottom. If n is less than 25, all tests must be passed. If n is greater than 25 and a test is failed, refer to the diagnostic plots. So we first look to see if any tests are failed, and since we failed tests, we then check the sample size. Then we go to the diagnostic plot. So step 1, check your p-values. We fail them. Step 2, do we have at least a sample size of 25? Yes. So now we can look at the diagnostic plots. Amazing work. Let's bring out my parrot. Where's my parrot at? Where's my parrot at? I'm going to bring, I can't click my parrot. Tiny Brian's parrot. He's over here. Wait, Tiny Brian's parrot, come over here, man. Oh, little parrot going to help me out right here. Let's do this. Got to have him on my shoulder right here. Going here to the end. Who won? Make sure to email me. Third place is going to be Fuzzy Snail. That's an interesting snail right there. Second place is going to be Epic Bear. Epic Bear, you came back. And first place, leading almost the whole time, 19 out of 20, Focused Lobster. We saw you the whole time right there. Brian's parrot. You got to go back to Tiny Brian.
What are you doing stealing my parrot? GG, everybody. GG. Tiny Brian's parrot, come back here, little guy. Whee! My Hello, parrot. Thank you. He's back. He's a good parrot. Burp. Yeah. I'm out.
Bye-bye. What happened to my voice? Tiny Brian is trying to sound like Brian. Great job, everybody. Excellent work. I'm going to go grab some more dinner after that ice cream I had earlier. But if you have questions, let me know. These were the questions people missed right there. Some good review questions, but we will be reviewing Wednesday before the test. On Monday, we're probably going to talk more about multiple regression, start going into some indicator regression. Let's throw out 100 more points right here. But really good review. Excellent work, everybody. Good to hear Harmony and everybody. Good practice. Please email me if you have questions. I'm going to go respond to some Discord more later, and I've got some emails to respond to. So message me if you need me. With that, everybody, it's been a great evening, great practice. Go get some dinner. Go relax. You're welcome, Charlie. You're welcome, Brian. I'm going to go eat some dinner. Bye-bye. Oh, thank you, Mun, very much. Please email me if you won. First place, $50. Second place in Amazon gift cards. Email me. You're welcome, Max. And great job, everyone. Great job, everybody. Good practice. If you got questions wrong, don't worry. Write them down. Practice the theory. Ask those questions. You mean go study? Nah, take a break. We've had such a long day. We've had a long day here on Stats 101, and it really is thanks to everyone who's been here practicing, and I really appreciate it. I'll just tell you this much. First stats class I took, I think I made like a C+. I didn't ace all my stats stuff. Eventually, after a while, it just starts to click, and you're like, oh, well, that's the standard error. That's the estimate. And all of a sudden, things start to make sense. It's only through repetition. It's like playing an instrument. You're not going to learn how to play piano in a week or in a month or in a year. You're going to learn how to play piano over a period of time. So we do that. We get better here every day. Natalia and Kayla and everybody and Brendan and Carson and Max and Mun. Have a great evening. Bye for now, everyone. Bye.